Hello everybody, welcome back and welcome to the second day of React Native U. Good morning, good afternoon. Welcome to everybody from all around the world, no matter where you are. We are here today all together on this live stream. We are streaming straight from Poland, from Kuttig office, from Wrocław, and I'm really excited for another day full of React Native related talks. So just before we get started, a couple of important informations. We have Discord channel where you can ask us questions and we will answer them during Q&A panel, and the Q&A panel will not be hosted during this live stream. We will have a special React Native show podcast that we are hosting at Kuttig as well, and during this podcast we'll answer your questions. So if there is anything that you would like to learn more about or something that you would like to be explored a bit more in depth, please leave us a question and we will try to answer it during the podcast. Two more things before we go. Obviously we have React Native EU hashtag, we have React Native EU account on Twitter, so use the hashtag, follow us on Twitter and let your friends know that we are here live so that they can also join us and that we can all together go through the talks today. So that is a second thing I wanted to tell you. And the third thing is that the agenda of this live stream is on the React Native EU website. So if you would like to learn what is it coming up after my introduction, go to React Native EU and check it by yourself. So that's everything I wanted to tell you. Now we are ready to get started. So let's start with the first block today. Before we start, just a reminder that talks during this live stream are grouped within blocks so that it is easier for you to follow them and tune in for the talks that are exciting and important for you. So the first block today is going to be native modules and contributing to React Native. And why these two are together? Well, I think that there are a lot of things in common when it comes down to contributing to React Native and native module. In both cases, you have to learn how to set up React Native on your local machine, or you have to learn a bit about native code. So if you learn one thing, the other will be easy for you as well. So yesterday we had some talks about performance and some talks about, architecture and changes that are coming to React Native. So if you would like to be part of these things or if you would like to contribute to them, our first talk today will be very, very important and useful for you. And so let's continue and let's start with the first talk by Fabrizio, and he is a freelancer from the React Native community, and he is going to talk about contributing to React Native, how does it work, what are the steps that you have to follow, and what you can do, and how you can do it so that you can change something in React Native by yourself and send a pull request, which is something that everybody would appreciate. So let's welcome Fabrizio on a React Native EU virtual stage, and let's learn about contributing to React Native and how we can all be part of the React Native framework.
Hello, my name is Fabrizio Bertoglio, and today I'm doing a presentation about the challenges that React Native developers experience when building mobile apps with React Native, and how we can learn from these challenges and improve the platform. My experience with React Native from the challenges I had during while building my own mobile app, SurfCheck. The app took around 1 year to build, and I had the chance of experiencing several difficulties with React Native. So the number one difficulty is the development environment, which sometimes would break and have some issues. Number two issue would be installing the native dependencies, as I was not using Expo, I was using React Native, and configuring and installing dependency would take a big quantity of my time. Unknown limitations from React Native ecosystem, not knowing sometimes functionalities that, trying to build the functionalities that are relatively hard to build with React Native. For example, in 2019 I tried to build a pinch to zoom functionality to allow users to zoom to take videos and zoom with a pinch gesture, which is was relatively difficult to build in 2019, while in 2020 new pull request has been merged to ReactNative camera, and now it's possible to do it. It's really easy to build. Upgrading ReactNative from 0.59 to 0.62 was another big challenge. Took a lot of my time. And also, again, issues. I experienced issues with flat list, with callbacks on end reach not being triggered correctly, zeta index not working as I expected it to be working in CSS, and then also complexity of the functionalities. For example, I used the ReactNative maps to display big number of points of surf spots on the map, but when zooming out and using custom images as pins instead of the default pins provided by the ReactNative maps library, I would experience issues with performance issues. The next slide is focusing on how this experience that I had personally building over 1 year mobile app are also shared by other developers and in our community, and how trying to maintain writing pull requests and maintaining ReactNative. I went through or read several of these issues, and had opportunity to read also the opinions of other developers and their view on ReactNative, on the issues that they were affecting them, and reading their opinion. And of this I came out with 4 points. For example, the first point is the style prop. So the style prop, which should work as a CSS. The developers would sometimes be disoriented by the fact that the style prop would not exactly work like CSS, and there's a couple of issues I refer to here. For example, issue 27333 and 25441, which are mostly issues where for example, the user was trying to assigning a touch handler to a view or a touchable opacity, and the parent has is contained in an absolute positioned container which has no height and no width, and for this reason the touch is not triggered, because Android and JavaScript and HTML are very different APIs, and it is relatively challenging to have a style prop that acts exactly like CSS in ReactNative. There are some limitations to this, and that sometimes will make developers be really disoriented, and not because they cannot understand the underlying, they don't know maybe the underlining Android API, which causes these issues. Then the same issues is with zeta index. So the Android API, which is behind the zeta index, is different from the API which is behind the zeta index we use in HTML and CSS. And for this reason, the index behaves differently, and can be time consuming, can take a time for the user to guess the correct behavior. Then the third point is performance limitation connected to the ReactNative bridge. Also here there's an popular open issue in the ReactNative repository about text input becoming really slow when the user types very fast, because the on-change events will bubble and reach some sort of limitations in the ReactNative bridge. So then also limitations from the ReactNative libraries. It's hard to understand before installing a library what actually the library can do and what are the limitations, and sometimes it does not cannot fulfill our needs. So the getting started to solve issues with React Native is relatively easy. The first step is we need to install React Native from source and add it to an example application as a dependency. There's a guide in Facebook React Native wiki called Building from Source, which will guide us through the installation of all the dependencies, configuration of the environment variables, and then on how to add the React Android project to our example applications. Once we added the React Android project to our example application, we will be able to see in the node modules directory there's a folder called the ReactNative, and inside that folder called ReactNative we can see the React Android project, we can see the Java libraries, and we can debug Java, and we can use the debugging tools I will talk to in the next point. The second important point is creating a minimum reproducible example which will recreate the issue we have in React Native without any additional source code or without any additional functionality that is not essential for creating the issue. Then the third point is debugging, is using the different tools we have available to collect information that help us understand what is the issues with React Native. So the issue could be connected to the JavaScript libraries, including the React Native, and we can use the JavaScript debugger tools, Flipper, React Native debugger, or just a simple console.log to log in the console the output of the different variables, functions, and or to understand when some functions are invoked, and to understand how the code works without having to inspect every line or reading every function. And then if the issue is not connected to JavaScript, or if we need an additional level of detail, then we can read the Java. In the case the issue is for an Android issue, we can read the Java libraries and we can debug those React Native Java libraries with Android Studio. We can set a breakpoint at a certain line of the Java code, or we can and then we can run the emulator to reproduce the example, reproduce the issues. The Android Studio will stop at that specific line of code, and we can evaluate the statement, see the variables and the different functions and methods, so the value they return, and use all this information to try to understand which line of code is actually causing this issue, and which line should be fixed to fix this issue. The third point is really important. I think the debugging tool is also logging the console, which is very fast. Doesn't require us to stop in the program execution. It will be more lighter, and the resource affect lighter our performance in our computer, and we can both log JavaScript and Java at the same time to see both sides what they're doing, and it will help us to understand how the source code works. And the most important point, I think, is the fourth point. Most of the issues are very simple, and they're easy to solve. Most of the issues, they just they lack a reproducible example, or the reproducible example is not a minimum reproducible example. So there's many functionalities included in that example that will distract us from the real reason. The most of these issues, most of the Java React Native libraries are based on the Android API, which rarely have problems. So we just need to understand exactly which part of React Native is not working, and then fix it and find a simple solution for that problem. A good way to start with React Native is starting with a library, with a native library, which will be easier than contributing to React Native. An example here, I'm talking about React Native Camera, as I started with React Native Camera, contributing to React Native Camera before React Native. And React Native Camera will be easier to contribute to a project like React Native Camera or another sensor API, another native API, as the library is smaller, has a lower level of complexity, is easier to, there's a fewer number of files there. It's easier to understand how the library is built, and it's easy to memorize the source code. Additionally, working with React Native Camera for me, it was a great opportunity. I had the chance to work with the React Native bridge, to use the React Native bridge, and which is relatively complex if you read the React Native source code, but is relatively simple when you are using the API as a third party, the React Native API as a third party. And I think it's very important to understand the connection between JavaScript and the native API, and this contributing to React Native Camera for me was a great opportunity to get to understand how third-party libraries are built on top of React Native. Additionally, it's an opportunity to get familiar with the React Native source code and start learning about Android and iOS API. We display the output in the terminal from the QR code scanning in React Native Camera, and then we can open the debugger, the Android Studio debugger, and open the barcode scanner async task file and set a breakpoint in the process. We display the data width, the variables data width and data height, which define the width and height of the image. As I can display in the README of my pull request, we display, I made some screenshots of the images, includes ruler to display the dimensions in pixels. The image has 1440 and 1080 of width multiplied height. We are scanning in a horizontal mode, and we can display the values of the pixels in the rulers, and also we can display them in Android Studio. In the debugger, we are using the planar YUV luminance and source from ZSync constructor, which takes several parameters. The first parameter is the YUV data, the image in format YUV, and then it takes data width and data height of the image, and takes in left and top, which is the top left corner in this case, the starting point that we use to crop the image. So we define, we pass those information to the constructor here. I display in the debugger, we pass data width, data height of the image, and then we pass mrect.left, mrect.top, which represent the top left corner, in this case in horizontal, when scanning horizontally. As I'm not spinning the image, the data, I'm not spinning it and converting it to portrait. We're scanning it. We start from the top left corner, as displayed in the image, in the video, and then we can see in the ruler that so the left is the position of the top left corner from the left side, which is 250, and the same is the output we get from when evaluating the variable. Now we display the result, the mrect.top, which is 300, and is the distance between of the top left corner from the left side, as we can display in the ruler, from the top. And then we pass the width and the height of the image. So the testing library will use these 4 parameters, left, top, width, and height, to define the top left corner where to start cropping, and then we'll draw a rectangle with width 915, height 600 around our barcode, and we will use this to restrict the area, use it to decode the barcode, which will increase the speed and it will optimize the process for decoding. We then create a binary bitmap, an image, and we pass this bitmap. We execute the decoding. As we can see, the result will be the result of the text we display is the same text we display in the terminal, and this is a successful decoding process using the cropping functionality of the testing library. The next bug is next issue from ReactNative. Is a simple user interface bug. As we can see on the right, the phone has a yellow view background, a view with a yellow background, which has a keyboard avoiding view, and the status bar on top is set to translucent. So the yellow view will display under the translucent status bar. For this reason, in this case, the yellow view has additional height of around 50 pixels, which is the height of the status bar. And when we display the keyboard, when we display the keyboard, a keyboard did show event will be sent, and will send a payload of few informations to send to JavaScript, to ReactNative JavaScript, the height and the coordinates of the available visible view. When the keyboard hides, it will show a white area in the bottom, and this is just because this is the reason of this is because the view height. So mVisible view area.height does not include the height of the status bar. While simple fix for this is just using mLastHeight instead of mVisible area view height, mVisible view area.height, and replacing this with the correct variable will fix the issue. So it's very simple to solve, and it's also very easy to understand this as it's very visual, and this is the characteristic of many of the issues we have in ReactNative. They're easy to understand as they are user interface issues, so we can display the output inside the phone. The next issue is numeric font weight. So numeric font weight, you can see on the left that the numeric font weight from 100 to 600 to 900 does not work. It does not have any effect, and this is because there's a new method called typeface.create, which accepts additional parameter for numeric weight, and this is only available since API 28. So also this is another easy fix. Just we check for the version that is API. If it's higher or equal than API 28, then we use this typeface.create, and we pass the numeric weight so that it can display like in the right side of the screen with different level of weight. Text input inside a scroll view. So the next issue also here, also very simple solution. So it's at least in some situation it's not possible to scroll a text input when it's inside a scroll view, because the onTouch event will delegate to the parent view, and this is mostly caused by the can scroll horizontally and can scroll vertically methods, from the Android API, which do not really work with Gravity Center. So it's very easy also here solution. We just disable Gravity Center when the editing text is being edited. When the cursor, we touch inside the text input, we set it to gravity left, and then this issue from the Android API can scroll horizontally method that does not tell us when we finish scrolling a text input is not we don't have this issue. So it's a really simple solution. The next slide, an additional issue we have in Android source code, a runtime error called we'll say Android graphics drawable constant state new drawable on a null object reference. And without going in the details of this issue, this is caused by the text input default drawable we are using with the ReactNative Android theme app compact. This Android theme we are using when we generate new projects with Yarn, ReactNative init, our some project. When we run this command, by default the ReactNative will use their template. The ReactNative CLI in this case will use their template to generate a project, and this template uses the Android theme app compact. Android theme app compact provides a default drawable. So a drawable is background, like an image for background for the text input, and this text input drawable causes this issue. So the simple solution is just change the template, so that the template uses a custom drawable instead of the default drawable, and this drawable is exactly the same as the previous drawable, but does not include those elements that trigger the runtime. So to reach the conclusions are ReactNative issues right now. In the issues we have open in our open source project are many of these issues are probably relatively easy to solve, and there's no need for Java or Objective-C knowledge to solve those problems. There's no need for Android or iOS experience to solve those problems. We just need to follow this the guidelines included in the ReactNative wiki, and then that I referenced from this slide from this presentation. Set up your development environment, use all the tools that will help you provide the information to solve those problems, and then the steps will be 4. So the first step will be reproduce the bug. The second step will be create a minimum reproducible example. Remove any part of functionalities that are irrelevant for that issue and may make the problem harder to understand and to solve. Then finding the ReactNative source code responsible for this issue, causing this issue. So research inside the project for pull requests that reference that had to do that can provide some information on how that functionality works. Searching for simply searching for in the open source project for those keywords and finding and then debugging those functionalities. And then once we found the source code responsible, we probably have to understand the Android API, which is being used by the iOS or the iPhone API, which is used by the specific functionality, and understanding that and try to implement a solution.
Thank you, Fabrizio, for this really exciting stuff. I'm happy always to see people trying to make contributing easier, and trying to let everybody know how easy it is to contribute to React Native once you nail the basics. So let's move on to our next speaker, which is a friend of mine, Pavlos. And Pavlos has been a speaker last year as well, where he was talking about Upgrade Helper, a tool that helps us upgrade React Native projects. So he is an author of that, and he was here to talk about the story behind it, the steps that he did, and what is it that he did to actually make that happen. Today, on the other hand, he's going to speak about slightly different topic, which is Xcode. Now, we all heard about Xcode. By some people, it is referred as a sort of mythical tool that nobody understands. Pavlos today is going to talk about Xcode, the details and basics of it, the Xcode and iOS project structures, and some nuances that will help us actually understand what is it under the hood that is happening when we are actually running React Native project. So he is going to take the learnings and takeaways from building Upgrade Helper and other tools from the React Native community, and based on them, he will tell us what he learned about Xcode and iOS project structure and all sorts of different iPhone-related topics. So let's welcome Pavlos on the React Native U virtual stage and learn about Xcode and everything that lives inside it.
Hello everyone, my name is Pavlos. It's nice to be part of React Native EU 2020. So my talk will be about Xcode complexity and how we can avoid this and simplify this for all React Native projects. So let's get started. So my name is Pavlos. You can find me online as Finis. I enjoy using and improving React Native. I've been using that for almost 5 years now. Yeah, it's a great technology and I want to make it even better. What we've noticed is that Xcode has been a struggle for many users, especially coming from web or native Android development. And it's a struggle because it is a new tool and many people are unfamiliar with it. The problem is also that a lot of settings need to be edited from Xcode UI, which is not the easiest. And definitely the file format of the project file is not very Git friendly. So we can see here that this is the UI of Xcode, and when we're trying to edit settings in here, it's not the easiest for a new user. And then when we check the upgrade helper, like here, we can see that there's a lot of, text here, not the easiest to comprehend. Many times also the differences, the diffs are basically just IDs being changed for the same files. So that's not helping. And of course we see things like this where a block of code or a block of this project file has been moved a few lines below. Again, creating a diff that looks complicated, but really nothing changed. The React Native core team and the community team have been working hard. There have been a lot of improvements and a lot of features shipped the last few years, and the tooling surrounding React Native has been getting better too. The biggest difference was made by adding CocoaPods that made linking basically way easier and simpler for everyone. And then the upgrade helper helped with people doing manual upgrades a little bit easier. So I've had this idea for a while now. I thought it would be very nice if the Xcode project was basically something like the package.json file. And by that I mean have one file where all of the Xcode project is defined, and then we don't have to mess around with settings inside Xcode. Looking for that, I found Xcode Gen. This is a project that already exists, and basically it can take a project YAML file, and using that it can generate the Xcode project file. So basically imagine that the project YAML file is the same as our package.json. So this is the place where we define all of the settings and the options and everything that we want to specify. And then the same way as we run yarn install, we would run Xcode gen generate, which is the generation function. And then we would get, for packagization, we would get a yarn log file that we commit, and we don't really care what's in there, but it is what we need when we have the same project in a new computer. And in the same way, we would get the project file for Xcode generated for us, and it will be the same or very close to same in a different computer. So the way to set this up for a new project, I have made this repository here that we can see the steps as well, but the steps are basically we need to install two tools. One is the Xcode gen and the other one is Xunique. The first one is for generating the Xcode project file, and the other one is for making the project file a little bit more consistent, more idempotent for handling the diffs and moving it to a new computer. Then we would have to copy a make script that is very simple, and then just get the project YAML file for our React Native version. A better way to do this is if we do a demo. Let's do that. So like I said, here's the repository. First thing, like I said, we will need to install Xcode gen. I have this already on my machine. And then the next thing would be to install Xunique. Again, I have it on my machine, so I'll skip these two. So the next is to copy the make file. The make file is up here, and we can see that basically it's just a bash script, very simple. It's creating the main JS bundle file, which is a file that the React Native project is including, but is generating when we run yarn start. So it doesn't exist yet. We create it just so that we can generate the Xcode project, and then we remove it again. Then we run pod install just to make all the CocoaPods and the linking done. And then as a last step, we do Xunique so we can make our project basically easier to commit. So let's do that. I have a demo project here. Let's make sure that it actually runs before we do that. So I will open the demo project in Xcode, and I will run it. So I started the packager here on the left, and I will click play on Xcode. All right. Let's see if that worked. So the build succeeded and it's starting up. This is basically a React Native application that I initialized with 0.62.2, and it's basically the template. I haven't done any changes to that. Yeah, so as we can see, it's basically all here. The only thing that I have changed in the Xcode project is that I have removed the tests and the tvOS part of the application, just to make this whole setup a little bit simpler, but it's not hard to add this as well. All right, so like I said, the next step would be to grab this make file and move it into our project. So we will go in here and let's create a new file, call it make, and then we will paste this. The only change we need to do here is to make sure that we have the right name for our project. And then we need to make this file executable. Right, so now we have the make file ready. The next step is to get the right project YAML file. So if you go in the templates folder I have in here, I have one for every version of React Native from 0.62.0. We can create for earlier than that, but these are just easier with like all the CocoaPods integration. Right, so the demo project for me is using 62.2. So we'll just grab that. Let's copy this and move it over to our project, and we can see what it actually has in there. All right, so I will make a project YAML file, paste everything in here, and then we can go up here and see what's up. So the first comment is just the version of Xcode Zen I used to generate that. The name is the name of our project, so in this case it's demo project. All of these settings are basically settings that React Native template has by default. So basically I just copied them over in the form of Xcode Zen. Then we have also some settings for the compiler and for the linker and all the stuff. All of these you don't really need to care. This is more some things that the React Native init template has. Yeah, we don't need to mess too much with this unless there's like a specific problem. Then the next important thing is the targets. So the targets we can see here is the application that we will generate basically. So again, we need to make this or name it correctly. So for us, it would be a demo project. It's an application for iOS, and the sources, the native source files are in the demo project. We can see this if we open our files here. We can see that in the demo project, iOS, here we have the demo project which has the native files. So that's why this comes here. After that, again, we have some things that the React Native template has, some build scripts. We don't need to change much here besides the names. So after I've saved this, the next step we can see here is basically to run the make script. So let's do that and see what happens. So I will run make, and we see that it's using Xcode Zen to generate. Then it's using pod install to link everything. And as the last step, it will also run xunique to make sure that the project file is simpler to diff basically. So if we come in our Git application here, you can see that as the main change is adding the make file, adding the project YAML file. Then we have a couple of small things from Xcode that we don't really need to care about. It's just Xcode versions generate this file slightly differently, but these are basically, we can just commit them. And then as the last thing, we will see the project file here has a lot of changes. A lot of changes that, like before, is, for example, just the IDs changing, things moving around. So the first time we run this, we will have a lot of diffs happening here. But if I, for example, stage this, the next time I run this, we should have much fewer, or maybe not even any diffs at all. All right, so it's generating, and let's see the diffs now. So we have some diffs, and as you can see, it's basically again not really any changes, just moving things around. Unfortunately, this we cannot avoid right now because xunique is a little bit old, so it hasn't updated everything. But this is simple enough to understand that nothing has changed, then we can go ahead and commit this. So as the next step, let's go to our Xcode project and run it again and make sure that it actually works. We can see here that the names of the files or not the names, but the sorting of the files has changed, just because xunique is also sorting everything. All right, and as we can see, it builds normally and it runs again, and we have our application like before. Right, so as one last step, let's go and and change. We will see this in a little bit. We will see this in a little bit. Okay, let's go back to our presentation. Right, so we just saw basically how to install or integrate Xcode Zen in a new project or in a project that we already have. Adding new libraries after we have added Xcode Zen it requires a little bit of change, as we will see. For libraries that don't have any native code, like for example Ramda or Lodash or anything like that, nothing changes. We just run yarn add and then the package name and everything is done. Adding libraries with some native code, for example ReactNative permissions, for this we need to change slightly what we do. Before we were doing yarn add and then the package name, and then we would go into the iOS directory and run pod install to make the linker run. Now what we have to do is replace pod install with running the makefile. The makefile, like we said, is going to generate the Xcode project, and then it will also run pod install. So basically it just makes sure that everything will be correctly generated. We can also see a commit here that I have that I made in a demo project. So in this commit I'm adding the permissions library and using it. So I have some changes in the app.js, which we don't need to care about. And the first step was to add the ReactNative permissions. After yarn install, of course, I have the changes in yarn lock. Then ReactNative permissions also need some changes in the pod file, which I did. And then also in the plist file. So after I have done these two, my next step was to go in iOS directory, run the makefile, and that generated the new Xcode project file. So we can see that here we have some changes, but again, not as crazy as we used to get. And we can see that the name, for example, up here is check pods manifest, and here it's the start packager. And then a little bit further down, we have start packager and check pod manifest. So we can see that basically, again, some of the code just swapped places in the file. Unfortunately, we can't completely remove this, but we see that only these parts changed and not all of the IDs in this file, basically. And then, of course, the makefile, part of it is running the pod install, so this generated a new pod log file. So again, yeah, adding libraries with some native code is requires a little bit of a change, but not a big one. As the last step, we can add a library by basically adding native code ourselves. So to do that, basically, again, not many things change, but it does have a little bit of a change. So we would need to create some native files with or without Xcode in that case. So that becomes a little bit easier if we want to not use Xcode for this. And then we need to just make sure that the target sources in our project YAML file are the directory that our new code lives in. So I have a commit here. Let's open this. Again, in the same project file, I have added some native code. So these are my files for the native code. It's just a view basically that has blue background, very simple. And we can see that it lives in my project, iOS directory, and then the name of my project, and then the file. So I made these using Xcode, but I didn't have to. And then the next step would be to add the JavaScript code for it. This is the file where I'm exposing the native component to JavaScript land. And then here is where I'm actually using it to test if it works. And then as the last part is, like we saw here, is to again run the makefile. And the makefile will generate the Xcode project. And again, as we can see, like it added the references to the new files. Again, it has swapped these two scripts. Not too bad, because we can see that the main changes are basically up here, adding the native files for us. All right, let's go to the next slide. Right, so how would we upgrade our project the next time there is a new React Native version? The easiest way would be to go to this repo and grab the latest template. So if we go here, like I showed before, there's the templates directory, and in here, whenever there's a new version of React Native, a new file will appear here. Most of these have very small changes between versions. Specifically, for example, for all 62, they are the same, and for 63, it has a couple of lines changed, and then everything in 63 is the same again. If you don't want to do that and you want to make the change yourself, we could do this by looking at the upgrade helper. So we can see if there's anything interesting. So this is a little bit vague, so let's go and look at this. For example, in 62.2 going to 63.0, there are a few changes. Let's ignore everything that's not the Xcode project file, as we know how to upgrade this. But we will see that, for example, there is the Xcode project file here. Let's look at the changes. So we see that one of the changes is removing the launch screen. If we have gone through this upgrade, we would already have this file removed and added the new one. So in that case, we would have to, like the old way would be, we would have to go to Xcode, remove the old file and add the new file and make sure everything is aligned correctly. But in this case, using project YAML file, we wouldn't need to touch anything inside Xcode. We would just remove the old launch screen file, add the new launch screen file, and then run make install or the make script file. So if we scroll down here, again, we see a lot of ID changes. For this, we don't really need to care, as now they're just auto-generated and usually they stay the same. And if we go a little bit further down, we will see that there is one change here that is a little bit interesting. Let me find this directly. So there is one called iPhone OS deployment target, and this changed from 9.0 to 10.0. This change, normally we would have to do through Xcode in the Xcode UI, but now we can more easily do this with Xcode Gen. So again, in the demo file, in the demo project I did the upgrade to 63, and let's see what changed. I made all the changes in the native files. Like I said, I removed this file, I added this file just with my code editor, and then I run the make script, and before running the make script, this is what I changed here in the project file. I changed the deployment target for iOS from 9 to 10, and only with that change, running the make script, it generated the new Xcode project file for me. So I didn't have to do anything in Xcode, and I get automatically the removing of the old file, adding of the new file, and then we can also see further down that the iOS deployment target also changed to 10. And basically that is also the change in the repo that I have made here. So this project YAML file for 63, you will see that it has 10. So it's very easy to just grab the template file from the repo, but if you want to do it yourself, you just need to find the right project YAML name and change it. So as my takeaways, Xcode Gen is great to keep all these complicated updates or upgrades a little bit more simpler. So when we have the change like we saw before, and then we have to make a guide basically to help people unfamiliar with Xcode go and do the right changes. It would require a lot of like clicking around Xcode's UI and trying to figure out where everything is. Whereas with the package YAML file, we can just do a change same as we saw before, just basically changing something in the YAML file, and then have the Xcode project generated, and then everything is exactly as it should. So that makes things much simpler. The second takeaway is Xcode Gen has great documentation. You should go check this out if you want to make your own project YAML file or want to have any customizations on it. You should go to the repo and look at all the project specification that I have, all of the documents. The code is also very simple, so whenever I find something or I can't find something in their documentation, looking at the code is also very, very simple. The third and last thing is that Xcode Gen right now doesn't have a way to generate a project YAML file from an existing Xcode project. So basically the other way around that I showed here. But this is something that is being worked on. So whenever this is out, in theory, we could have a React Native Xcode project, and then we would run Xcode Gen, like reverse generate, and then we would get a project YAML file, and we could just keep that as our package JSON, like I said, and we can just customize that where we have already, instead of starting from an empty file from scratch and generate it ourselves. That means that basically whenever there's an Xcode change in a new React Native version, we need to, like we did before, we need to find the interesting change. So this like iOS deployment target, for example, and find the right YAML file, the right YAML name for the project YAML file. But a way easier way would be to just go to the repo that I showed and just grab the latest template file for our React Native version that we want to upgrade to. There is some work to be done still, and this is to basically keep the templates up to date. This is not very hard, thankfully. The way that everything works is that React Native has a new version, and when that happens, there are all the diffs generated. When we have the diffs, these diffs go to the upgrade helper, and then we can see everything whenever we want to go from any version to any version. And when we look at these differences, these diffs, the next step would be to look for these interesting changes, like I said, and put these into the project YAML file. So in theory, if you have Xcode Gen in your project, and there's a new version out, you could just grab the latest template file, and that would basically require you to do no changes for your Xcode project file from upgrade helper. You would just run the make script, and all of the changes would be there. So like we said in the beginning, the project YAML file is your package JSON. Your make file is basically yarn install, and then your Xcode project file is just your log file. You don't really need to care what's in there. You just need to commit it and have it so you can actually use it in another computer. Same as with the yarn log file. The second part of the work that needs to be done is that I would like to make an RFC and a PR for adding Xcode gen in React Native, so we could have it in the init template. So my suggestion would be go to the repo I showed, try to add Xcode gen in your project, make issues if you find something that's not working for your specific project or any other like more general problem. And you can also find me on Twitter, and I would like to fix this and make it as general as possible so I can also add it in React Native template. And finally, thank you so much. I have some links here to this talk, to the template repo that I showed, where I work, some personal stuff, blah, blah. Thank you so much, and have a nice evening. Bye.
Thank you, Pavlos. Thank you for that. I think that, Xcode errors and Xcode issues and understanding Xcode in first place is always the thing that, makes developing React Native applications easier. Now that we know how to contribute to React Native and how to resolve Xcode related problems and how to actually understand Xcode and how it works, we are ready to start actually writing native code, right? And that's what our next speaker, Monica from Major League Soccer, will tell us about. She will tell us a bit about bridging native modules to React Native, so we will finally get deep into writing native code and native modules. So let's welcome Monica on a React Native virtual stage, and let's get started with writing some native code.
Hi everybody, my name is Monica Restrepo, and I'm part of a very cool group of software engineers at Major League Soccer. I am also a computer science student and an occasional open source contributor for A Great Helper, a React Native community project. Most of our products at MLS are built or being built using React Native or React.js, among, of course, other technologies. Today, I will cover a topic that has been really major for our mobile app at MLS. It is bridging native modules with our React Native application. And here is the agenda for this talk. I would like to first briefly go over that thing called the bridge. Then go over the state of it, a close-up to React Native's new re-architecture, and also talk a little bit about the bridge under the hood. How is this piece of React Native's architecture set up, and how does it really look like inside React Native's core? Lastly, I would like to cover a bit of how to bridge native modules with React applications for those who are just getting familiar with the platform or need a refresher of how to actually connect the bridge to React Native applications. Okay, so what is that thing called the bridge? Let's quickly revisit the concept in the React Native context. The bridge is that part of React Native's core that allows us to send and receive messages to and from JavaScript land. Let's say you have a native module that most likely belongs to a third-party provider, like in our case, or you definitely need it to develop in native language for performance or capability reasons. Or let's just say that you need to use an API that has been written in native code. This platform module or API, however you want to call it, needs to communicate with the rest of your app that you have been arduously developed in JavaScript, and also manages the rest of the functionality, of course. This is where the bridge becomes necessary. It allows this communication between those two pieces of your app through asynchronous JSON messages that get batched and sent from one side to the other. It saves us from having to re-implement things in JavaScript. So, what is the state of the bridge as per today? Emily Jensen from the React Native core team at Facebook talked on this conference last year about the direction of React Native for 2020 and React Native's re-architecture. Among the changes she talked about, turbo modules, initializing React applications without the bridge, and the introduction of JSI were the most important in what relates to this presentation. So let's have a refresher on what these topics entitle. The 2020 version of React Native will include what is known as turbo modules, which is what is considered the new generation of implementing the interaction with the native side. Turbo modules in conjunction with Fabric allow for the UI manager to create something called the shadow tree directly in C++, which reduces the overhead of calling JavaScript methods from the native side and significantly improves the responsiveness of the user interface. Turbo modules will include improved type safety between native code and JavaScript and allow for less overhead calling methods from JavaScript, and also are faster to start up. Let's move to what the new initialization process for a React app will be. Initializing without the bridge is also one of the major changes in React Native's rearchitecture. During the initialization process, React Native loads classes, initializes native modules, initializes view managers, and sets up the bridge. The new architecture aims for no longer eagerly initializing native modules and view managers, and instead, those two processes will be initialized lazily, which again is a significant improvement in performance for our apps. This new way of initializing our apps is directly related to the introduction of GSI. GSI stands for JavaScript Interface, and it's an API that allows us to interact with the JavaScript engine from C++. It allows us to create JavaScript runtime, load the JavaScript bundle, and call functions between C++ and JavaScript. It also allows us to create and access JavaScript objects from native code, which is actually pretty cool. GSI is the promise to solve the main issues that having a bridge in between native modules and JavaScript content implies, such as bottlenecks and the lack of awareness from one side or the other with asynchronous batch messages. And okay, I am going to stop here for the recap of what the new architecture of React Native is. But if you want to get a deep idea of the evolution of React Native and the process of coming all the way to what it is today, I recommend to watch Lorenzo's Chandras. Pardon if that's not the way you pronounce your last name, Lorenzo. His talk during React Advanced 2019 conference in London, where he takes a deep dive into React Native's evolution. Also, there is this article by Remy Gallego that summarizes React Native's rearchitecture in 2020. They both serve me as the references to prepare this part of my talk, and I consider them really useful. So it is worth you go and check it out. Okay, let's continue with the bridge. Even though Facebook's plan to eventually get rid of the bridge is coming a long way, many applications and modules are still and will still be using previous versions of React Native while their migrations to the newest versions happen. We have recently gone through a React Native upgrade at MLS, and the process wasn't simple due to the multiple native libraries and modules our app runs within. So for the time being, I think it's important to keep in understanding that this is an important piece of the architecture in React, and it's going to stay there for a long time. This clearly leads me to take you into the mystery of how the bridge works under the hood and how it is set up inside React Native's core. One of the things that really motivated me to do this talk today was the fact that most of the time we seem to talk about the bridge as this abstract, magical thing that allows the functionality I described before. But personally, I wanted to demystify it so I could understand myself and I could share with you what I found under the hood. Let's start with the way it works. The blue circles in this graph correspond to the activities taking place in the native side of our app. Events such as timers, network, touch gestures, and Bluetooth take first in this side. When you see the old implementation of React Native, these events needed to be initialized at the time that the app was being initialized, even if we weren't going to use them then. Okay, so these events initialize, then a data collection of those events and any parameters associated with them also happens, so they can be notified to the JavaScript side. Once these messages or notifications are ready to go, the bridge serializes this payload and passes it to JavaScript so it can be processed there. From JavaScript, we can also call native methods, and this happens as well here in this process. They are also sent to the bridge where they are serialized again, so the native side can process them and finally make the required update. So it's a back and forth process. With the new implementation, Turbo modules will allow the JavaScript code to load our modules lazily and to keep a reference for them, so we don't have to go back and forth through this whole process and even use batch JSON messages. Let's take a look to the way the bridge is set up inside React Native's code. In order to have a native module that can communicate with the JavaScript side, we first have to create a module and expose it to the bridge, so this is aware of the module existence. In order to do this, React enables the React export module function that registers the module as an external function and makes the implementation of the function available at link time. That also creates a method module name that returns the optional macro. A macro is a set of functions to be performed during build time that returns a parameter called JSName in case you want your module to have a name in JavaScript other than the Objective-C class name. And lastly, it declares a load method that calls the above declared React register module function to actually make the bridge aware of this module. So when the app is loaded into memory, it will call the load method for every class. This, again, corresponds to the logic before Turbo modules. In the new architecture, the use of React export module is not required, since some of these modules might be loaded lazily, and all the UI operations are handled by a series of cross-bridge steps. We actually can see some reference to both the old bridge and the React XX bridge that uses the new JavaScript interface and allows for calling modules in the JavaScript thread. This React XX bridge, or the new bridging, allows us to internally check if a module's block is run in the JavaScript thread. So this can execute synchronously, or if it is not, to dispatch this block in the main thread. Something important to note here is that the new re-architecture will have 4 queues that allow for React to prioritize tasks as they are happening. So we will have the synchronous queue, the synchronous bundle, the asynchronous queue, and the asynchronous bundle, which kind of compose what the concurrent mode is. Depending on what type of module we are using and whether we want to load it eagerly or lazily, we will dispatch that module on the respective queue. The bridge class allows us to do this. Another important method, and this is continue with the next step, of this native JavaScript internal setup is the React register module. This method goes through the modules array, creates an instance of every module, stores a reference to it in the bridge, gives it a reference back to the bridge, so we can call it both ways. And it checks if it has specified in which queue it wants to run. Otherwise, it will give it a new queue separate from all the other modules. In other words, all the React register module function does is to add the class to an array so the bridge can find it later when a new bridge instance is created. All right, so once the bridge has been initialized and set up, it can find everything that was exported. Modules, methods, everything can be done at load time. Let's move into what's after the bridge knows about our modules and it has been initialized. In a background thread, we list all the methods for each module. A call to and call the methods that begin with RCT export, so we can have a string representation of the method signature. This is part of what we call the configuration of modules. And it is important so we can have the actual types of the parameters. For example, if you have if you want to know at runtime if a method has an ID or a name as a parameter, this would be the way to know if it is an NS string or, for iOS specifically. Continuing with the process of getting a module to the other side of the bridge, we have some JavaScript related setup. After the bridge has been fully initialized, React uses the React JavaScript executor. This is to abstract away the JavaScript execution context. It also allows to do more expensive work, like initializing the JavaScript core on a background thread. It also saves some work since only the active executor will receive the setup call, rather than all the executors available. Then we move into the JavaScript loader, which's role is pretty intuitive. Just loads the source code from whatever provider was specified. Usually it unloads the source from the packager during development, or it loads it from the disk in production. Once everything is ready, we can load the application source code in the JavaScript core virtual machine that will copy the source, parse it, and execute it. In the initial execution, it should register all the common JavaScript modules and require the entry point file so it can work. The modules that get generated from JSON in these previous steps will be available to JavaScript for us to use. So I will say as a wrap up of this whole bridging process that everything initializes with some calls to the native modules in the native side. Then some calls into JavaScript side during execution happens. JavaScript calls all the methods in the native modules and enqueues these calls that have to be executed in the native side. When JavaScript finishes, the native side goes through all the enqueue calls, and while it executes them, makes the respective callbacks and calls to the bridge. So then the JavaScript side uses these callbacks again to do whatever it has to do with them. So now that we have a better idea, I hope, of the underlying logic of the bridge and how React makes it possible to interconnect with the native side of a mobile application, I think I can go over the process of bridging one of our native modules at Major League Soccer. As again, a reference for those entering the React Native world or a refresher for those who haven't done it in a while. Let me start with the how did we get here. Our web and mobile apps at MLS use Gigia as their identity manager. For those who aren't familiar with this platform, Gigia handles registration, social login, user profile, and preference management features called. So our app's login screen used to load a web view that will interconnect with our web login page, and then subsequently send our users login information to Gigia. We were having several hiccups with this approach because it wasn't necessarily the most performant, and we were missing some of the capabilities that Gigia had to offer with their native SDK. So we decided that we were going to rewrite the whole login experience as a native module, so we could use these capabilities written by Gigia in native language. And also, to be honest, it was a great opportunity for us to get more familiar with the native side of our app, which we had been pretty much outsourcing at the time. So here's what we previously had. As you can see, we had a web view with some JavaScript injected in it, and we will let our login authentication repo take care of everything else. As you can also imagine, this was adding some development overhead. Our team was rather small at the moment, and having to switch back and forth between repos so we could be able to debug and change things was adding an unnecessary step to our process and for instance, slowing us down. So we implemented our login screen in both Kotlin and Swift. On the Kotlin side, as you can see here, there are two basic functions being called from the React Native, Kotlin side to the React Native side. One of them is the React application context, which serves as a wrap to verify that application context is passed as a param. Exploring a little bit in the React context, what it does is that it creates a Catalyst instance, which manages the gateway to Android JavaScript C. And as a reminder for what context is, for those who don't remember, context is the representation of React Native's environment in Java. It includes the initialization of various native modules and packages. Okay, so this other method is a React method interface, which is used to mark methods that are exposed to the React Native. This applies to the derived classes of base Java module, which will generate a list of exported methods by searching for those which are annotated with this tag. And then this annotation adds a JavaScript callback for each of them, of the methods, right? The iOS side of things looks a little simpler. For our native module, we mainly use the React event emitter class. So our module could emit events from the native side into JavaScript and vice versa. This is just a look to the file structure for our module and the steps we use to package it, right? So in Kotlin, we created the package where the view manager instances are created, and then where our module will be packed. And finally, registering the package list for our native modules. For iOS, respectively, the file structure is very similar, with an addition of a Facebook wrapper required by our third-party provider, also, of course, written in Swift. We have also header files here that might contain variables, constants, and all the functions that our module will require to use. And the M files, where the classes of our modules are implemented, as seen in previous slides. As you can see here, the React extern method is used for every method that we need to be available in the JavaScript side, so we can expose it to the bridge and then use it there. And finally, when our bridge has been successfully created and initialized, we get to actually access it from our JavaScript code the way you can see it in this slide. We import the native module class and then call the specific module we would like to use. Now, with that, what's happening under the hood is that the bridge is looking through that list or array of registered modules that it has available and picking the one that we are calling in this particular case. The same thing happens with the methods exposed to that class. We can access them in, once the whole modules has been bridged to the JavaScript side, as you can see here. Okay, and I think that is all from me today. Thanks a lot for staying around to learn a little bit about this thing called the bridge. I am aware that this is a very popular topic among React Native conferences, but it's always worth knowing a little bit more about it. And thanks for the support of to the community.
Thank you, Monica. Thank you for that insightful talk into details of native modules. Now, with your introduction, we are good to go and move on to our next speaker, which is Dylan from Mux. And Dylan will talk a bit about maintaining and wrapping and bridging SDKs for React Native. Now, SDKs are just a variation of a native module that is dedicated to wrapping a certain native APIs so that we can actually access them from React Native. So it is not that you're writing something from scratch, you're actually making some SDKs accessible. And so Max is a company that maintains a lot of SDKs for many different features. Actually, they have around 22, so I think Dylan will have a lot of insights how to make that maintainable and easy and actually possible to do. So let's welcome Dylan on the React Native virtual stage and learn more about SDKs, React Native, and native code.
Hi everyone, thanks for having me at React Native EU. And today I will be talking about porting your SDK to React Native and how a small team maintains 22 client SDKs. So first, I'm Dylan. I am a senior software engineer at Mux on the DevX team. That's the developer experience team. Before Mux, I was a CTO and co-founder at Crowdcast, which is a live video streaming platform. That was from about 2015, and I did that for 4 years before joining Mux. And I have a background as a full stack software engineer for the past 10 years, and specifically for the last 5 years in the video space. And right now, with COVID and everything going on, the video space is a really, really exciting place to be in. So we're seeing a lot of unprecedented growth and new people who have not done video before that are starting to learn about it and reach for it. And it's really fun because I get to talk to developers like y'all and do that every day for my job. So one product that we have at Mux is called Mux Data. And what it is it's analytics for video. So if you think of a product like New Relic that tells you how your servers are performing, or you think of a product like Google Analytics, which tells you how your landing pages are performing, Mux Data tells you how your video is performing. And when we talk about video performance, we're talking about like the quality of service. So more like the like objective quality of the video viewing experience. We're not talking about like engagement. Engagement would be more along the lines of what is the most popular segment of a particular video, or which videos are being watched more than others. So engagement is not what we're talking about here. We're talking about pure like kind of engineering performance. So the video quality metric number 1 that we're talking about is startup time. So that is when a user taps play on their device, they don't want to wait. You want to minimize the startup time. This is also referred to time to first frame. What you'll find if you're streaming video is that if your video is taking a long time to load, users are going to leave. They're going to close your app. They're going to leave your website, and they're going to go somewhere else. So it's really important if you're building a video product to minimize the startup time. The second video quality metric that we're talking about is video quality. So there's kind of two dimensions to video quality. You have downscaling, which is, you can imagine, first of all, like the container that your video plays in, that's called like the video player. So downscaling happens when you have a big piece of video, big frame, and then you're squeezing that down into a small player. And the visual quality result is that video will still look good, but the problem is you're wasting bandwidth, and that's bandwidth that you have to pay for on your servers. That's bandwidth on the user's device that you're wasting. So that's not ideal. The opposite of that is upscaling, which is perhaps worse. And the upscaling is the opposite, where you have a small video. So you can imagine like a video that's the size of a postage stamp, and you're playing it in a player that is the size of a deck of cards or the size of an iPhone. What's going to happen there is you have to upscale the video. The player is going to have to upscale the video. The visual quality is going to suffer. It'll look blocky and have a poor resolution. It'll be kind of obvious when you're looking at it that this player is like upscaling the video. So you want to kind of hit the sweet spot there, where you don't want to upscale too much, you don't want to downscale too much. You want to kind of serve the right size video for the right size of the player. And these days you're dealing with people that are watching on Apple TVs, big 4K TV sets in their living room, and then they're also watching on little tiny mobile devices and on all kinds of various networks. So this problem actually gets to be quite difficult. The next one is smoothness. So smoothness is when we track rebuffering. So rebuffering is when you're watching a video and then you see a spinner. And what happens is the player like downloads and streams as much video content as it can, and it usually keeps a buffer of video so that if you have a network problem, it can kind of catch up. But what happens when the player runs out of buffer is that it's in a rebuffering state and you'll see a spinner. And if your users are seeing a spinner when they're trying to watch your video, they are having a bad time and they are probably going to close your app or leave your product. So it's really important to track these metrics when you have a video product. So overall, what our Mux video product looks like is this is like what one particular video view looks like in our kind of UI. And you can see here, this person watched for 1.2 minutes. Overall experience score is 50 out of 100, which is quite bad, pretty poor. The video startup time was half a second, which is pretty good. The rebuffering percentage really killed them here. Out of 1.2 minutes of watching, 24% of that time was spent rebuffering. So this user was actually quite patient. I would kind of expect that people would bounce and leave if they're experiencing that much rebuffering, especially right at the beginning there of when they started watching. So this is like the example of what one view that Mux tracks looks like. But when this really gets valuable is you get tens of thousands, hundreds of thousands, millions of views, and you look at this data in aggregate, and you can see how your videos are performing on Chrome versus Safari versus Mac OS, Windows, in North America, in Australia, in Asia, and you can kind of look at all this data, and you can really kind of optimize your video delivery to increase your performance metrics. So that's kind of about Mux and the data product and what we do. And now let's talk about what this means for React Native. So the first thing to note here is that all these metrics that we're talking about, these are all client-side metrics. So we're measuring like the end user's experience from the video player. So these are not metrics that we can collect from the server side. From the server side, you can kind of tell how video is being delivered, and things like that, but you can't really tell what the user experience is from the server side. So these are all client-side metrics. So it's really important that we build SDKs in order to track these from the actual client side of the users that are watching. So this is what we did. We built an SDK for every video player. So that includes smart TVs. You see like Apple TV, Roku, Chromecast. Mobile apps have players. Android has a player called XO Player. iOS has a player called AV Player. On the web, there's a bunch of various players. You have Video.js, is kind of maybe the biggest open source one. You have the regular HTML5 video element that you might be familiar with. Google has one called Shaka Player. There's a whole bunch of players out there. And at Mux, in order to deliver this data product to our customers, we had to build an SDK for every one of these major players so that our customers can install our SDK into their player. We can monitor that playback experience. We can monitor those three metrics we're talking about, the three main ones at least. So we get a bunch of data from the video player that can help us make these informed and give our users some informed, actionable data that they can use. So in total, we maintain, last time I counted, 22 player level SDKs. And the reason I'm here today is because I'm talking about our newest one, which was for React Native Video. React Native Video seems to be the kind of like de facto video player for React Native. It's the most common one we hear about, the most commonly requested one we saw folks using. So recently we added that one on, and that's the one I worked on. So first to talk about a little bit about our SDK architecture. So I think this is important because we really don't have a big team that's working on these SDKs. So what we did is we created a core library in each of these three languages. So we have a core library in JavaScript, a core library in Objective-C, and a core library in Java. And each of those core libraries really holds all the kind of business logic of how these metrics are calculated. And then it has a kind of a defined API. And so everything's sort of abstracted. All the business logic and all the calculation of those metrics is abstracted up into the core library. And then what we do is we have like a lightweight player-specific wrapper. And this lightweight like player wrapper, that's the SDK that our customers will actually install and initialize with their player. And what happens is they initialize that SDK in their player. That lightweight wrapper, what it does is it has a dependency on one of the core libraries, and then it hooks into like the APIs and the events that are available from the player, and it just dispatches those events into the core library. So then the core library can calculate those metrics and actually make the HTTP requests to send data to the Mux data backend. So that's how it works, and this has really allowed us to kind of move fast because every player has different idiosyncrasies. Players name things differently. Some players will have one callback, and then some players will not have that callback, but they'll have a different one that's sort of similar. So what this allows us to do is kind of just have that thin wrapper to kind of like normalize all the events that are coming across these different players and send them into our core library. So when I started to approach this for React Native video, my first look was like, we have a lot of SDKs for web players, and we actually have like kind of a standard HTML5 video element SDK where if you're using the HTML5 video element, and a lot of the players out there are just using the underlying video element, we can just hook directly into that element and monitor that. So my first thought was that maybe React Native video, maybe if I put in a ref to that video component, I'll get back a object that looks like an HTML5 video element, and then this would be super easy. I can probably do this in a day, and we'll be off and running. What I found is that's not quite how it worked. It wasn't that easy. So when I grabbed a ref to the video component in React Native world, it didn't have any of the properties and methods that an HTML5 video element would have. So I was pretty out of luck with that like super easy approach. So I just decided to rewind things and start back from the beginning. So our typical workflow for building like a new web SDK is create a new SDK skeleton, pull in the Mux JavaScript core library as a dependency, and then just dive into the documentation for the player and see what callbacks we have, what APIs that player gives us, and hook into all those and just dispatch the events into the core library based on what the core library expects, so we can start tracking things. And in total, it's probably about 300, 400 lines of code for like a new web SDK. And remember, the reason we're able to do that allows us to kind of spin up new web SDKs rather quickly, because all of that complexity and business logic, it lives inside the core library. So just the individual player wrapper is pretty thin. So I tried to do this with React Native video. So I created a new SDK skeleton. And that skeleton was really just kind of like has the build steps and things like that. Next thing I did is I pulled in the Mux JavaScript core library as a dependency, and right away it was crashing. In a React Native world, our JavaScript core library was not playing nice. So the first thing I ran into is we were using a browser API and called under window.performance.timing. And that was not available in React Native. It looked like we were calling window.performance.timing DOM content loaded event end, and that was not available in React Native world. So we had to kind of like wrap that in a conditional, make sure we're not accessing that if it's not available. So that was an easy fix. Next thing is we were using this library platform.js. It's popular on NPM. This is a way to kind of detect browser, operating system, manufacturer, and version data like that. And this was just not working in React Native. I don't remember if it was crashing or if it was just not giving me back any useful information. So that was just not an option. But that wasn't too painful. All I had to do there was detect the platform within using React Native's tools. They have this like a platform. There's this platform module you can import from React Native, and that allows us to detect what operating system, some version information. So I was able to pull that out and then use that instead of relying on the core library to automatically detect it with platform.js. So that was fairly easy. And in total, that was really all I had to deal with. Otherwise, what I found was that React Native was actually much more compatible with the various JavaScript libraries and browser APIs that we were using than I thought it would be. I kind of thought I was going to run into a lot more things that we were using that we were kind of depending on being available in the browser. But it turned out that it was actually quite compatible. So that was fairly straightforward. Now, next step is to check the player documentation. So I pulled up the repo for React Native video. I see all these events. I see how I have like an onload start, on progress callback. That on progress callback is really important. I have a seek event. This looks like I probably would have everything I need. I can hook into those events, and that would allow me to kind of get the right timings, and as long as I can get the playhead position, and we can kind of be able to calculate a lot of all the metrics that we need for like a base level integration. So the way I design this is with like a higher order component pattern, which is I commonly see in React. So you can see what's going on here. This is sort of like, this would be like what my SDK would export, and that the kind of end user developer would interact with. So we export a function that takes a component as an argument. And here we're calling it wrapped component, like right there on line 3. And then what we return is a new function component. So now we have a function component, and it takes all the kind of properties that the video component from React Native Video would expect. So you can pass in all the normal properties that you would pass into the video component you're using. And then what our SDK does is it kind of hooks into all the callbacks it needs, and then returns your wrapped component. And the wrapped component that it returns would be your normal video component that you were using already. But we've kind of like overridden the callbacks and hooked into them. And then you see the way we do this is like, you can still use those callbacks if you were using them in your own application, but we've kind of like just hooked into them so that we can update some local state and that we can dispatch events into our core library. And so that this is kind of end up what the public API looks like. You can see right here, line 2, import video from React Native Video. That's kind of like, if you were not using this Mux wrapper, you would just use that video element down on line 11. But then what we have on line 6, line 3, we import the Mux React Native Video library. And then on line 6, what we do is that's a function, so we pass in that video component into the function, and that returns a new function component that we're here calling Mux Video. So now on line 6, that Mux Video component, it's going to behave just like the video component that you're used to from React Native Video, but it just has some extra options for like Mux metadata, and then it's going to be just doing some monitoring and tracking for those performance metrics. So this is what I came up with, and it ends up working quite well, and it was kind of like an easy API for anyone who was using React Native Video already. If they just wanted to layer in that Mux functionality, it makes it just like a really easy way for them to do that without having to like refactor a bunch of things. And the current status of this is that it's in beta. We have a few customers using this in production, and we actually ran into a few outstanding issues that were related to some inconsistencies that we see between iOS and Android callback behavior. This wasn't totally unexpected. I imagine that's kind of like, seems to be the people in the React Native community, there seems to be like little inconsistencies here between the different operating systems. There seems to be a common theme that comes up. So that's what we ran into. Nothing's like totally blocking, but it is a couple outstanding issues that we want to get fixed before we like fully release it for general release. So right now it's in the beta state. And the little bit, I want to talk about the alternative approach. So it turns out that React Native Video, under the hood, it uses AV Player for iOS, and it uses Exo Player for Android. And basically, if you're using iOS, it's kind of like really the only player that's available, and it comes baked in with iOS. And Exo Player comes baked in with Android, and these are like by far the most commonly used players on these platforms. And as a result of that, we already have great support and great SDKs for those two underlying players. So what we could do, if we wanted to kind of take an alternate approach here, is we can kind of bypass React Native Video entirely, and we can just hook in to the underlying AV player on iOS, and we can hook into the underlying Exo player on Android, and then we can kind of like pull in our AV player SDK and pull in our Exo player SDK to do that, and just rely on those SDKs for monitoring those underlying players. And that has some benefits. The benefits of this approach is that we get to like reuse SDKs that we are already built and that we know are well supported. And the other benefit is that we can bypass React Native video altogether and avoid those kind of cross-platform inconsistencies that we're running into. That would be kind of like the main motivation. But ultimately, we decided that we don't want to go down this path, at least not right now. And the reason for this is it's kind of twofold. So it's a little bit, in a way, it's a little philosophical, but there's also a practical aspect to why we would maybe not want to go down this approach. The first is that, like, from our SDK's perspective and from the user's perspective, the player that they're interacting with is React Native video. The fact that React Native video uses AV player and uses XO player under the hood is more of like an implementation detail. So it's more so from a philosophical perspective, like theoretical perspective, it kind of makes more sense to just interact with the actual player itself, that interact with the APIs that are given, that are exposed by that player, and not worry about how that player is doing things under the hood. And the other reason for that is, like, if we were to kind of hook into AV player and XO player directly, we would be really relying on how React Native video it happens to be using those operating system players. We would be relying on how specifically React Native video uses AV player. And then later down the road, let's say a new version of React Native video was released and React Native video doesn't have any breaking changes in their API, but that could still break our SDK because we were relying on them to use AV player a certain way. And then if some of that kind of underlying details changed of how they were using AV player, then that could potentially break our SDK. And then we could be in a situation where we don't have backwards compatibility. And even though React Native video puts out a version that doesn't break any of their exposed APIs, because they change some underlying behavior, that could potentially break some of the tracking we were doing. So this alternative approach, we're not completely out on it, but that was kind of the thinking that went into it, and the reason that we would like to approach this in a way that we've done already, which is to just use the APIs that React Native video gives us and just rely on that functionality, because we know if React Native video releases a new version, if they change their top level APIs, that would be like a breaking change, and then we can kind of guarantee the compatibility in a better way. So that's it. Thanks for coming to this talk, and if you're doing anything with video, I would love to talk to you. At Mux, we're kind of like all things video. This was just kind of like a small part of what we do, and part of my job is just to talk to developers who are using video every day. So if that's you, please come find me and we will chat. Thank you very much.
Okay, thank you, Dylan, for that. It's been a really interesting talk, and honestly, having that many SDKs for that many platforms, that is a serious challenge. Now, that wraps the third block. I hope that you liked it, and now we are good to go for a quick 15 minutes coffee break. So, grab your coffee, refill whatever you are drinking right now, and if you are not drinking anything, make sure to grab some water, because we are about to dive deep into the next block, which is GraphQL and data management, and that might be something really, really interesting. So, before you go to the coffee break, just two important announcements that I'm making every break. The first one is Discord channel. Make sure to join us using the link here and leave questions if you have any for the Q&A panel, and also tweet ReactNativeEU hashtag to let everybody know that we are streaming live right now. So, see you after 15 minutes and enjoy your coffee break. I'll grab my coffee as well. This conference is brought to you by CodeStack, the React and React Native development experts. Meet us at codestack.com. Hello.
Wake up in Wrocław, get up and get at 'em. ReactNative EU is on and it's happening. Check in to check up on all of the latest news and strategy. Man, it's kind of the greatest.
Welcome to ReactNative EU 2019.
Keynotes that unlock a new world of insight. Lightning talks this cutting edge? It really seems so right. Networking with everyone in the React Native community, from the thinkers to the linkers, we're all here in unity. Q&As that dive deep into code DNA, and it's all covered here in only 2 days?
Especially when it comes to trouble.
After the last session, we're gonna party, okay? Food, drinks with good vibes and dope karaoke. High fives all around, it was good to be here. Can't wait till the next one. We'll see you next year. calling all builders and tinkers, the doers and linkers, the ones who create it from scratch and the ones who code a clean patch. The code ninjas, the toolers, the thinkers, and don't forget the seasoned drinkers. Your open source lovers, your time tracking haters, the JavaScript junkies, and the wild bug wranglers. Your community is here and it's waiting for you. It's the first of its kind and it's called ReactNative EU. Core contributors and insights and networking and knowledge, all for ReactNative, it's in our language. Find us in Wrocław, Wrocław. Difficult to pronounce it. Your good vibes are here, go on and announce it.
Hello and welcome back after the break. I'm back, Elvis as well is back, and we are good to go with the next blog, which is again GraphQL and data management. So, our first speaker in this blog is Kadi from Formidable, and she's been a speaker at ReactNative EU last year as well. And today she's going to talk a bit about urql, which is a library for GraphQL queries and essentially working with GraphQL and React Native that they've been working on at Formidable. So without further ado, I'm really excited for this talk and learn more about how urql works and why should I choose it compared to other libraries in the community. Really exciting question. Hope this talk will be really good and interesting. So Let's welcome Kadi on our React Native EU virtual stage and learn about urql and how it works.
Hello, and thank you for tuning in. Today I'm going to talk about building React Native applications using GraphQL. More specifically, I'm going to talk about my experience doing this using urql. A little bit about me. My name is Kadi, and I am an engineering manager currently working at Huidobro. If you've not heard of Huidobro before, we are a JavaScript consultancy, and we are very passionate about all things to do with JavaScript, GraphQL, and open source. urql, the library I'm going to be talking quite a bit about today, is actually part of Huidobro open source. So what are we going to cover today? I'm going to talk about why you might want to use GraphQL with React Native, the challenges I've faced using GraphQL with React Native, and something that I've been asked quite a bit about recently, which is the differences between urql and Apollo client in this context. What this talk isn't about, it's not going to be an introduction to GraphQL. Now, it doesn't mean that you need to be an expert. You don't need to even have shipped anything using GraphQL or even used it, to be fair. If you just know what GraphQL is, what it's used for, and you're kind of familiar with the syntax, you'll be able to understand this talk. Why use GraphQL with React Native? Well, for the most part, you might want to use it for the same reasons you might want to use it with React on the web, but I'll cover a couple of more React Native specific reasons. One big thing for me is the smaller payloads. You only request what you need, which is a huge selling point of GraphQL in general. When we're building mobile applications, we need to be especially aware of how much data our applications are consuming. So for React Native, this is especially important. The other thing, and perhaps the main thing for me, is that you get an API contract that's typed. Even if your API engineer shipped the API without any documentation and didn't tell you what any of the queries are called, the schema has to be shipped with the API, and the schema is typed. So even if you don't actually have any documentation for the API, using the schema, you have a pretty good idea of what can be possible to do with the GraphQL API. Now, when you're using GraphQL with React Native, I will assume that you are using a GraphQL client. I think you could, in theory, do it without, but it would be a lot of work. And the last two things I wanted to bring out are actually related to using GraphQL with a client. One of the main things for me is that you get built-in caching. Now, if you ever worked on a React Native project that's using a RESTful API, you'll probably also use Redux to store all your data in your own Redux state. And that's a very good way of doing it, but it's quite verbose and it's quite a lot of boilerplate. And one of the main things that using a GraphQL client will give you is that you have built-in caching, which means you don't need to manage the data on your own, and that's incredibly powerful. I was once part of a project where we actually moved from REST to using GraphQL, and the amount of Redux code we got to delete and replace it with nothing because it was handled in the library was incredibly satisfying. The other thing is around offline support. Now, for mobile applications, offline support is quite important because when it comes to websites, your users generally don't expect them to work offline. But when it comes to mobile applications, they get a bit pissed off if they can't use them on the tube. Now, offline support isn't always built into your GraphQL client, but because they already have caching, you're kind of halfway there at least. And that's incredibly important. Now, suppose you're starting a new React Native project with GraphQL and you need to choose a client. At the moment, there are 3 GraphQL clients to choose from that I'm aware of, and these are Relay, Apollo client, and urql. Relay is the original GraphQL client, I think, and it's built and maintained by Facebook. Apollo client is the one that we're most aware of, I think. It's the first kind of open source one that came after Relay. And urql is the new kid on the block that's quite recent, and it was built to be more extensible and kind of learning from community learnings after Apollo client. I personally haven't used Relay. I read the documentation, it looks decent, but I have used Apollo client extensively and urql quite a bit, so this talk is going to be focusing on those two. A bit of history of my experience using React Native and GraphQL. My very first React Native project, which was in 2017, we actually used GraphQL on it, and that was using Apollo client. After that, I've worked on various React Native projects, both with and without GraphQL, and both greenfield and brownfield. But so far, those have always been using Apollo client. Now, this all changed early this year when I started a greenfield project where the client wanted us to use urql on the front end. I was incredibly excited to do this because I've heard a lot about urql. I've been really keen to actually try it out in anger. Let's talk about urql. urql is a blazing fast GraphQL client that supports React, Preact, and Svelte, which is something that I got from the website. From my experience, I can also attest that it supports React Native. I asked one of my colleagues, Phil, who is an urql core maintainer, for a quote about urql for this talk, and he said, "Our place in the ecosystem was to challenge existing solutions and to be flexible enough to adopt new ideas." That's basically the core idea of urql. It's to be incredibly flexible and to be extensible, and you can opt in and out of each part of the ecosystem. Now let's get stuck in and look at some code. How to get started. To get started with urql, we start by adding the library. We add urql and GraphQL. Then we create a client using the create client function exported from urql. The only mandatory config option for the client is the URL for your GraphQL endpoint. Then we use the provider that's also exported from urql, and we wrap our application in the provider and pass the client in. This gives everything inside the provider access to the urql client. Now, on the other side, I also added the equivalent documentation for Apollo, just so you'll be able to compare and contrast them. They're quite similar. You still start by installing the client and GraphQL, but when you create the client, you notice the Apollo client has a new keyword, insinuating it's a class, which I guess doesn't matter to the end user anyway, but that's something that's different. And also you pass in the cache yourself, so that's one of the config options. Now let's look at how we query data. For both urql and Apollo, we use the use query hook. I think Apollo actually has various ways you can request data. There's higher order components, there's render props, but I'm going to use query because that's the coolest way, as we know. So to request data, we use the use query hook. On urql, we pass in an object, and one of the keys for this object is query, where we pass in the string with the query string. Now this use query returns an array where the first item is the response object, which has all the metadata around whether the response is currently fetching, or if it's errored, or if it's returned with the data. The second parameter on there is actually the re-execute function, so you can re-execute the query. Now to contrast this with Apollo, it's quite similar, it does the same thing, but the API is slightly different. Namely, in order to pass in the function, you have to use the GraphQL tag library to convert it to the GraphQL AST yourself. Whereas in urql, although it does do that, it does it under the hood, so you don't need to worry about it. The other difference is the return syntax. So for Apollo, it returns a object with loading, error, and data, and the re-execute function is also part of this object. Let's talk about exchanges. Exchanges are a series of operations that transform the input stream to the output stream. If you're going to compare them to anything, they are quite similar to Apollo Link, but they go a bit further than that because they're more of a central concept. In fact, when I asked Jhaveri, who is also a core maintainer of urql, for a quote for this presentation, he said that urql is so extensible that even the cache is an exchange. Let's look a little bit more deeply into how exchanges work. urql is a stream-based library, so we can imagine the data as a stream, and usually it's likened to a stream of water, which is why I've depicted all the exchanges as pipes. So between the use query and the data coming back, we have a bunch of pipes or exchanges. And let's look more deeply into the default exchanges that come pre-packaged with urql. The first one we have is called the dedupe exchange. The dedupe exchange removes duplicates from pending operations. Now this is very handy if you might render a React tree and there's two components that have a use query with exactly the same query. This dedupe exchange would spot that and remove one of the duplicates because there's no point doing exactly the same request twice. And therefore both of the use query, components using the use query, will be able to consume the same instance of the data. Another exchange that we have is of course the cache exchange, which is the default caching logic using document caching. And finally we have the fetch exchange, which basically takes the operation, sends it to the API using fetch, and adding the results to the output stream. And between here, you could write your own custom enhancements in your own exchange. Now, why might you want to do that? Well, a very common example would be an auth exchange. You might want to write an exchange that adds a authentication token, authentication header for each request. This is what I had to do, and I'm going to take you through what it takes to build your own exchange for adding a token to the auth header. Now, in order to create a custom exchange, let's look at an example of a no-op exchange. That is an exchange that doesn't do anything. Essentially what we do is we get the stream of operations, and we have the opportunity to update anything we want within these operations. That is to add things, to remove things, or just add parameters to the operation, and then before passing it through to the next exchange. Then calling forward with those new operations would be the last thing you do on your exchange. So the first thing I did is I looked at an example that already existed, which was how to add an auth exchange to React. Well, in this example, we take the token from local storage and we'd add an auth header to each request. So what I did is I basically took this example and made it work with React Native. The difference between React and React Native is that our storage tends to be asynchronous. So whether you use async storage or sensitive info, the request for fetching the data tends to be asynchronous. Thankfully, within the exchanges, we can use asynchronous operations, so I was able to update this map to be asynchronous. Now this did work, but I ran into a weird problem. I was using React Navigation, and in combination of this auth exchange and React Navigation, I kept having warnings that said that something was fired with no listeners registered. This is indicative of a memory leak, which was quite concerning. I noticed that this happened whether you used async storage, sensitive info, but it didn't happen if you just used a normal promise, which seemed like it was something to do with those libraries. At this point, I decided to abandon this line of thinking because the idea of doing an asynchronous request for every single request that goes through my library just felt a bit wrong. So I went back to the drawing board. The next thing I tried was fetching a token outside of the client creation and passing it into the auth exchange as a variable. Now this does work, but the problem with this solution is that when the token changes, for example, when the user's token has been invalidated and refetched, the client needs to be created, which means that I'd lose all the cache that was accumulated. Finally, this is a code snippet of what I ended up doing eventually. And something that I didn't realize before was that everything before the return in an exchange is stateful. Basically, what I could do is I could, when the auth exchange is initialized, I could start a request. I could start a promise to, for example, fetch the token from the storage, and then I could store it in a state within the exchange. And then within the auth exchange, I could pause the execution of the remaining queries until the token has been fetched. I'm not going to lie, building this auth exchange was definitely the most trickiest part for me for using urql. And I've been very keen to find a way to make it easier for others. So I've been working on a auth exchange, which hopefully should encompass all the requirements that you might have when building authentication. This includes adding the token to your header, fetching it from storage, and the refresh logic. This is quite an ambitious undertaking, and I don't know how it's going to turn out. I'm hoping it will be a catch-all solution, but it might end up being a bunch of code snippets. Check my Twitter after this talk for an update on how the auth exchange is going. Why is caching so important? Caching means that when we query the same piece of data several times with little time apart, we won't have to do an API request each time, just the first time, and on subsequent times we can use the cached data. Caching is also the first step towards offline capabilities. As mentioned previously, urql comes with document cache by default. You can set your caching strategy on a query-by-query basis using the request policy key. The default request policy for all the queries is cache first, and this means that the urql will check the cache. If the query exists in the cache, it will get returned. If it doesn't, a network request gets made. The other request policies are cache and network. This means that first we'll check the cache if the query exists, and if it does, return it immediately, but still do the network request and update the cache with the new data. Then we have cache only, which only reads from the cache and never does the network request. If the query didn't exist in the cache, you'll just get empty data. And there's network only, which doesn't look at the cache at all, but always does a network request. Now, you might also wonder how we could handle cache invalidation. That is, can we tell the query that, okay, we only care we only want this cache to be valid for a certain amount of time. And you can do that using the urql exchange request policy. In this example, the requests are valid for 1 minute, and after that, unless the request policy was set to be cache only, we refetch the query the next time it's requested. Now let's talk about GraphCache. GraphCache, in my opinion, is the best thing about urql. It's basically a more sophisticated cache, and it's more sophisticated because it handles interdependencies. In order to install GraphCache, you just install urql exchange GraphCache, and you add it to the list of your exchanges with a config object. Now, to see GraphCache in action, let's look at how you could handle cache updates after a mutation. Here we have a used query that queries a list of to-dos. And below we have an example of a mutation which will take a which will take a particular to-do by ID and update its title. When we've done this query and this mutation, how do we update our cache with the new title for this to-do item? Now, the first thing you might think about is refetch queries. If you used Apollo client before, you're quite familiar about it. It's kind of the quick and easy way to get your cache updated. And basically, it's an array of queries that you want to refetch after mutation has returned. And it basically is what it says on the tin. It works. But it's a little bit inefficient because you might be doing more network requests than you really need to. And urql actually doesn't even have refetch queries. All right, how else could we do it? How about we could manually update cache with the mutation results? Well, if you ever used Apollo client, you are definitely going to be familiar with update queries. I've certainly written many of those. What an update query is basically a function that gets run after a mutation is completed, and it will give you the mutation result and the cache, and it will basically give you the option of using that mutation result to update the cache however it needs to be updated. Now, this is incredibly flexible. It works. There's nothing really it can't do, but its downside is that it's quite verbose and quite tedious. And it might leave you thinking, well, if the cache is so clever and GraphQL is so typed, why can't we just let cache handle it? And with GraphCache, we can. With GraphCache, the cache is automatically updated with the mutation results. Now, I find this so awesome, I actually made a separate slide just for this statement. With GraphCache, the cache is automatically updated with the mutation result. The way it works is that each piece of data has a type name, which comes from GraphQL anyway, and an ID or a key field. And for example, here, when we have a mutation where we update the to-do, we also query the result, which should be a to-do item type, and we query the ID and whatever changed. And GraphCache will basically automatically update the cache based on these two values. The only gotcha here is that you need to remember to always re-query the fields in the mutation that have changed as a result of it. If the data doesn't have a reliable ID, which can happen, you can add it manually in the cache config. So you can basically create a dynamic key if there is a combination of items from the parents that make up a unique ID for the child. Or if there is no such combination of items, or if it just doesn't make sense for that field, you can opt out of cache updates for these values. Now, what if the mutation result doesn't return everything that gets updated? Well, in that case, you can also define manual update queries if you need to. So all of this logic around update queries, you can still do exactly that, just most of the time you don't have to. I've got an example here which is similar but not quite what I had to do on my last project. And basically this is, imagine you've got an application which has a bunch of to-do items, and you have a query for the current user, and the current user query will have a current user's to-do list. So if you have a to-do list in progress, you will have a current to-do list item on the current user. And if you update the last item in your to-do list as complete, you want to remove the current to-do list from the current user. And this is something that you can do by extending the cache config. You have an update key where you can add a update query for each mutation if you need to. So this, for example, checks if the completed percentage is 1. So if the to-do list is completely complete. And in this case, I will take the update query and remove the current to-do list by replacing it with null. So this is an example of a mutation, like updating something elsewhere in the cache. So again, we didn't have to refetch the current user, which is quite handy. Now, I talked about offline support previously. I won't go very deeply into it, but with Apollo client, there is a library called Apollo Cache Persist, which basically allows you to persist the cache of your Apollo client, and you'll be able to kind of replay your actions on top of it. I've actually done talks about this before. It's a little bit fiddly, but it is possible to do. With urql with GraphCache, there is actually offline support. Currently, I think it's in beta, but it's something that urql intends to support out of the box. So if you're interested in offline support with urql, I recommend reading the GraphCache offline docs on the urql documentation site. Let's talk about DevTools. urql DevTools have full React Native support, and it's awesome. You can see the network requests, you can inspect the cache, and you can execute queries using the DevTools. In order to add the DevTools, it's obviously an exchange. So in order to add it to your project, you add urql DevTools, and then you add the urql DevTools exchange into your create client. As a side note, you don't need to worry about the DevTools exchange in production because it automatically bails out if your node env is production. Then to launch the urql DevTools, you just run npx urql DevTools in your terminal. And this is what you get. I won't go very deeply into it, but this is what the urql DevTools looks like using an example project that I have, which basically lists a bunch of artworks from a public GraphQL API. Now, on the left, you can see all the requests that I've done. So you've got a list of artworks and individual artworks. You can query all the fields. You can see the types of the data. And on the right, you can also see metadata about that request. On the second tab, we have the events. And this is a timeline of all the queries and mutations that you've done with your urql client. And this is quite handy. It kind of it's inspired by the network tab in Chrome, and it basically aims to do the same thing. So you can see how long the requests took, what data was sent and received, and everything in between. And finally, we have kind of a GraphQL playground type thing. And this works quite similarly to GraphQL Playground that you might be used to. The only difference is that because it runs through, it's attached to your client, it uses the exchanges that you already built. So for me, for example, I'd already built an auth exchange. So my exchange added the auth header that I needed, which means that I don't need to worry about adding an auth header here, which is something that was quite tedious to do using the GraphQL Playground. In summary, using GraphQL with React Native is awesome. I really enjoyed it, and I will definitely be using it again. Apollo client was the very first GraphQL client that I used, and it's the one I've still used the most, and it's been very reliable and awesome. But I've got to admit, urql has won me over, and it's mostly to do with GraphCache. I love not having to write update queries and have the mutations updating the cache automatically. I also love the fast issue resolution, thanks to Phil and Yovi being completely on it when it comes to the issues. And also I love the extensibility first approach. Thank you so much for tuning in. Here's a collection of links related to what I discussed throughout the presentation. If you want to catch up around anything in this presentation or just about urql, feel free to reach out to me on Twitter.
Thank you, Kadi. Thank you for this really exciting and interesting talk. So, the question is to you. Will you use urql for your next React Native project? Let us know in comments and on Discord channel. So, now let's move on to our next speaker, Sanket Sahu from Geeky Ants, and today he is going to talk a bit about building real-time applications with JSON patches. Now, As we know, building real-time apps has been always a challenge because you have to maintain a lot of synchronization between different realms and you need to resolve conflicts. And so looks like Sanket has something to tell us a bit more in terms of JSON patches and how this works and why this makes a lot of sense. And now, if you've been following Sanket on Twitter for a while, you may have realized that he's been tweeting that something exciting is coming to be released during React Native EU. Now, I have no idea what he's going to show us, but I'm really excited for that. And so without further talking, let's welcome Sanket on the React Native EU virtual stage and let's see what he has prepared for us today.
Hey everyone, I'm super excited to speak at React Native Europe, and I want to talk about something that we built, which came out of a larger project. And today I'm happy to release that as an NPM library. So let's see what it is. So this is a design tool that we built, and recently we added the capability of multi-user real-time access in this one. So this is called as BuilderX. And it was announced at React Native Europe, I think, a couple of years ago. And yeah, so recently we added real-time multiplayer sort of thing to this, in which, say, the same layer can be selected by two different people accessing the same document, and they can change the different properties of the same layer at the same time at different locations. Like one of them can change the color, while other user can, say, change the size of this one. So that's my topic today, how to build real-time multi-user apps. And the secret sauce behind it is JSON patches. Let's see how we built it. So a little bit about me. I'm Sanket. I am a software engineer, CEO at Geeky Ants. I go by the Twitter handle Sanket Sahu. You might have heard about our contribution in React Native with the open source library native base. So yeah, what are JSON patches? Consider we have a document, a JavaScript document or an empty object. And JSON patches are like change requests, or they denote changes on a JavaScript object. So it has three properties. One is operation, path, and then the third one is value. So operation here, I'm going to add a property called hello, or yeah, and the value at that property would be world. So once I apply this, it gives me the next document or the next state as hello world. We can apply another patch to this to add, say, another property called, say, Baz with value boo, and we get the next state or the next document. So JSON patches can be applied using multiple available libraries that uses the standard. And let's see what we have chosen. So consider if we want to do this with Redux, and if we have the initial state as, say, counter as 0, and I want to change that count to, say, 1. So I can say that, okay, this is my JSON patch. At path counter, I want to use or change the value 1 from 0 to 1. And the operation can be add. We can also use replace because both of them work in this case. And yeah, we can dispatch this as a Redux action, and with, say, type patch, and with the payload as the JSON patch, we can update this state to the next state. And the reducer looks like this. If in case of patch, we are using a function called apply patches. This comes from Immer.js. Immer.js is a beautiful utility library by Michel, which also works really well with JSON patches, and it also has other capabilities. But I really like the JSON patches capability of Immer.js. So as soon as we do it, we can start replacing our counter. And this patch is really powerful because you don't need to write anything else after this, and you can change the entire state of your application. This gives you freedom, but it can also be dangerous at some point. So this example is available in Code Sandbox. Go ahead and check it out, and let's see how this goes. Great. So when we talk about patches, the question is, can we store patches over snapshot? Like instead of, say, persisting the document, that's the say final state or the current state of the app, versus patches. So there are obvious advantages of using or storing patches over a document, because if we store patches, we are storing the entire history of the state, and that gives us versioning, and also like we can go back and forth with everything what was done on the app state or the document. And we can anytime reach to a snapshot by computing patches or reapplying patches over time. But we can't really know that from snapshot. We can't really deduce patches from snapshot. So it's one way. It does increase the storage size, and computing it every time can be costly, computational heavy at the runtime. So there are advantages and disadvantages. Uh, Not only this, we can even use patches to sync data between two different systems, two different threads, which are, say, maybe miles apart on two different computers, or maybe which can, if we are sharing, say, data across threads, we can use patches. Let's see how that happens. So we have an empty document and we have a patch. And once we apply it, we get to the next state. Patches can be transferred over network or over to JavaScript runtime to different threads, because these are serializable. And it can be applied to the same document somewhere else, and we get the same resultant document. And that's pretty amazing, because if you want to build, say, real-time apps, or if you want to, say, create a replica of the object on the main thread and offload it to, say, a worker thread to, say, compute something, we can use patches to like sync objects. And this is wonderful. And this is the piece of, this is the algo or idea that we have used in our design tool that's syncing things all across the network and sessions. All right. And but it's a bit more when we have, say, network latency, or when we have conflicts between different sessions. So there's a bunch of things that we need to take care of. Something like optimistic update. Say if I updated something on the user side, and when it went to the server refused to accept that particular change and said, okay, this is in conflict with some other user that is updating the same document, or the same node in the document. So in that case, we need a way to reverse it, and also like maintain a buffer of what is committed and what is not committed, what is approved from the server and what is not. And then we also have to maintain the order of multiple patches, like which one comes first. And if the order is different, say, on one of the systems, and it's not right, then we need to reverse the order and go back to the place in the JSON patches history where it is all correct, and then reapply them with the correct order. And we need to work on conflicts. Conflicts can be resolved in multiple ways. It depends on what type of app you're building, and the conflict resolution works on the, like, it's a very specific thing. And to solve all these problems, we have tried to pull it out in a separate NPM library called as sync state. I'm happy to release this library. This is an experimental state management library for React, which works on JSON patches and also opens up the capabilities of history of remote syncing, and it works on the document. It makes it easy for anyone trying to build real-time multi-user apps. Let's see how that works. So sync state is based on Redux. It uses Redux internally and also uses Immer.js to make it easy on the surface. And yeah, it's all based on JSON patches for actions. Let's see how that works. So the API looks like this. Just like Redux, we have create document store instead of create store. And we can create a document store, and with the help of a hook called as useDoc, we can get an access to this document anywhere in the React tree, and we can then update that using setDoc. setDoc takes a callback function, and you can update doc.name is equal to something like sync state, or doc.anything is equal to anything. And this can be used in the app component with the help of a provider component to set the context where the doc is coming, where the store is coming from. And it looks like this function, say app, and then use doc, and then set name. And under that, you can use the document from doc.say something. Pretty straightforward. But you may ask, where is the JSON patch? Because we're not using any JSON patch over here. And the answer is it's hidden inside with the help of Emerge.js. So Emerge.js also generates JSON patches with a callback function. So you make changes on the draft state, and it generates a bunch of patches that can be consumed later. So the same example, like set name is equal to say set doc, where we are updating doc.name to something, can be rewritten with the help of patches like this. So set name can be a function which dispatches an action where we have type as patches, and in the payload we are like forwarding a bunch of patches. And in this case, say we wanted to change the name of the document to sync state, we are using that. So it's the same thing, but Emerge.js only makes it simpler. And the dispatch function can be is found as on the like second argument of the, or maybe third argument of the use doc hook. So sync state uses Redux, but it does not use React Redux. And here is why. Let's see how Redux and React Redux work. We have a store. It can be like here in this context, we are talking about Redux store. And Redux store forwards the data to the component using something called as connect method. So this connect method is the glue between store and component. And whenever the component wants to make a change, it dispatches an action, and the store receives it and then makes some change. It again forwards the data to the component with the help of connect method. Let's see what that connect method is. So consider this is the React's virtual DOM tree that is currently mounted. And in an ideal scenario, we would connect most of the component or all the components which are listening to the global state using this connect method. Even if just one of the nodes, one of the components needs a data change or needs to be updated. In case of React Redux, all the connect components are hit. And then connect method slices the part of the global state and then forwards it to the React component. And in this case, say just one of them updates. But connect method, all the connect methods are executed for sure for the mounted components. So this strategy is called as pull strategy of state management. This is perfect in case of functional programming concepts, wherein we rely on immutable data to re-render the components. This is totally fine in case of pull strategy. But we may end up in a bit of performance issues when there are a lot of connected components, or if we have smaller components on screen and we are trying to receive or listening to data in all those components. And that's where we have push-based strategies to update the component. Let's see how that works, or let's see how sync state works. So we have sync states store, and to pass data to component, instead of passing down the data or part of the global state, we pass down the path. And then the component fetches the data at that path in the document and then adds a listener to that path. And whenever the component wants to make any change to the store, it dispatches an action, which is JSON patch in the case of sync state, and updates the store. This time, the store emits an event, which is being listened by the component at the same path, because the component is updating some path in the JSON tree, and that can be listened to the components that is mounted on the screen. So not all the components are listening to everything in the global state in the case of sync state. Only the components that is listening, that is using some particular data, only those components are hit, and not all the components are hit. So this type of re-render or change detection strategy is called as push strategy, which is used by MobX, which is used by Recoil. And the sole reason for this is to achieve higher performance. So event-based updates for performance, that is used by sync states, use doc hook, and we have push strategy, much like Recoil and MobX. And JSON patch itself is treated as an event to re-render components here. All right, let's see an example. How do we build a counter example in using sync state? So you create a store. This time have some initial data as say count is 0. And then we can use the document and update it. We can create a function called increment, and then with the help of setDoc, we are updating doc.count plus plus. And something similar for decrement, setDoc doc.count minus minus. And the return method can consume those functions and the value. So we are showing doc.count and on-click increment and decrement. And it's available in the examples section of sync state GitHub repo. You can go ahead and check it out, play with it, and feedback. Anyway, then we have a history plugin, which helps you add undo and redo functionality to your document. And much like the previous example, we are creating a document, and as in the second parameter, we can pass a list of plugins that this document or this store would use. So in this case, we are passing a history.plugin plugin. And at any point, we can dispatch history.undo and history.redo to move between the series of states, or to undo a particular state change or redo a particular state change. And this is also available in Code Sandbox in the example section. Go ahead and check it out. And there is a difference here if we compare the undo and redo plugin of sync state with the undo and redo strategies that is used with functional programming concepts, or maybe Redux undo. So Redux undo stores the snapshots, whereas sync state history stores the patches. So instead of storing the entire states, or the entire state of each version in your history, sync state history stores the differences with the use of patches. It can be really useful to store patches over the entire state when we want to serialize undo, redo, or history, when we want to keep the history on, say, a persistent storage, because it's not going to cost a lot. But in case of the functional programming concept where we store the entire snapshots, it can be really useful, that because patches are like really small objects that denotes or signifies the changes in the document. And that's the theoretical difference between sync state history and Redux undo. All right, let's move on. Let's look at the next plugin. And this is pretty exciting, how remote plugin works and how JSON patches help us to achieve multiplayer or multi-user functionality, and how this plugin works. I want to give a big shout out to friends at Figma. They have written a beautiful article how the multiplayer technology of Figma works. And it's also very similar to how we have built it in the design tool Builder X. And also the same concept is pulled as a separate plugin here with sync state. Couple of examples from the article by Figma. So say if we have two clients and a server, both of them are connected to a single source. And if both of them change unrelated properties, say one of them changes the color, other client changes the size, then what happens? So let's see, like one of them changed the size while the other changed the color. So in this case, both the changes succeed without any conflicts and it just works. So when unrelated properties are updated, it should be accepted by the server in the persistent storage and also emitted to all the connected clients. Just works. In this case, the order doesn't matter because anything uh, received first and executed first, it doesn't matter. And the changes, what you see that is being communicated between the server and the client with the black dot, those are JSON patches. And the server keeps a history of those patches, which can also work for versioning. Let's see another example from the same article. If both clients change the same property at the same time, so what happens? So in this case, say client 2 changed the color and client 1 also changed the color. So in update is discarded because there is conflict with an unacknowledged value. And the thumb rule is that the last value written to the server wins. So the green color was received by the server in the end, like the first color change was yellow and the second one was green. So the green is accepted and it's emitted on all the clients that okay, green is something that is accepted, and that's the source of truth. But there is more than this when it comes to multiplayer, multi-user technologies. We need to do reordering and reverse the local patch. So we're trying to achieve those things and solve those heavy lifting and complex algorithm with this plugin. We have a server piece that stores the patches for persistence. It resolves the conflict. And then on the client side, we need a way so that we can store the patches in a buffer until it is accepted by the server. And if it is not accepted, and if the server sends a response back to the client saying, okay, this particular patch is invalid, then we need something like a way to reverse that patch. And it should also play well with the local undo redo of the connected client, because an undo on the, say, one of the clients should not undo the same thing on the other one. Uh, it should do, but the stack of undo and redo should be like two different. It should be local to the clients. It should make the change, obvious change to the other client as well, but the undo, it should only undo what the connected client changed on, not the other one. So these are few of the things that we need to take care of, and we have tried to solve it with remote plugin of sync state, and it's evolving, it's experimental. I would love to connect with the community and get some feedback and some PRs over here to solve, to make it more robust and use it in our applications. There are future possibilities of sync state. Right now, it's focused on more of document storage and document changes. Uh, we are trying to build a bunch of plugins that makes it more seamless to adopt. Say, we are working on REST and GraphQL plugins to seamlessly fetch and update remote data with local mutations. So if we treat our entire database, entire backend database as a document, and if we make some changes using JSON patch to that database document, it should automatically sync my local mutations on the server. And without the knowledge to the end developer, they can use this plugin and they don't need to worry about making API calls, be it REST or GraphQL. Local mutations automatically should sync to REST and GraphQL, and vice versa. I've seen some great examples of using JSON patches with the Spring Boot framework. So we're trying to go ahead and adopt those things here as well. And also want to build more community plugins for general purpose state management, like forms, API calls, persistent storage, and things like that. But we're not looking to reinvent the wheel. If we can consume the things that is available, already available with the ecosystem, we would love to find a way to use them. And yeah, so this is a really early release of sync state. A big shout out to the team, to the people who have built it. We were able to pull it out of the BuilderX repo into a separate open source library. Himanshu worked really hard in the past 2 to 3 weeks to get it off the ground and publish it. Rohit worked really well to put the documentation live. So a big shout out to Suraj, Ankur, Himanshu, Rohit, all of you. And I'm looking more uh, for more feedback from the community. Go ahead and use it. It's available. It can be easily used for general purpose state management for the entire application. And looking for more feedback and collaboration from the community. And thank you so much, guys. It was I couldn't come to Poland because of this situation. I would love to meet you guys in person, maybe next year. And thank you so much to the entire Call Stack team. Thanks. Bye-bye.
Wow, that's been quite a release, right? So, I can't wait for this live stream to finish. Maybe I shouldn't say it this way, but all I meant was that I just can't wait to get my hands on the sync state. And I'm really interested to know if you are also excited about that. So, question to you, are you going to use sync state? What are your feelings about it? Let us know on Twitter. Let Sanket know, because I'm pretty sure that he spent a lot of time on making this release happen. All right. So, let's continue our GraphQL journey now with our next speaker, Juha, which is a head of mobile engineering at Go4, and he is going to tell us about his story of migrating a large-scale app, and let me look that number up, with 200,000 weekly users, migrating that to the Apollo client. That sounds like quite a challenge. I can't wait to learn about all the challenges and problems that they had down the road and lessons learned. Pretty sure you're also waiting for that. So, let's welcome Juha on our React Native EU virtual stage and learn about that process.
Hello React Native EU. I am Juha Linnanen from Finland, the head of mobile development at Go4, and I'm thrilled to be at this conference again. I have been at all the previous editions of React Native EU, but this is my first time presenting. I'm a mobile developer with a native background, but the past 3+ years I have been using mainly React Native as my tool of choice for mobile development. Go4 is one of the leading IT consultancy companies in Finland, with over 600 employees, offices around Finland and also in Germany, Spain and Estonia. For mobile, over half of our projects are utilizing React Native, and we are quite happy to have it as our main mobile development tool. Today, I will take you on a journey with me on how we ended up using GraphQL on a React Native app, what kind of challenges we faced, how we solved them, and what was the outcome. The app in question is Yle Uutisvahti, which is a news application for the Finnish public service broadcasting company. For an app that basically targets only Finland, a country of 5.5 million, the app is quite popular. It has over 200,000 active weekly users, sending millions of push notifications each day. It is allowing the users to personalize the kind of news they are interested in and receive notification for the most important news for them. The app was first developed in 2013 and has won multiple awards, such as the Best Mobile Service in Finland 2014, as can be seen from the newspaper clip. The app has been under development for a long time, and the age was starting to show in the code. Features had been added here and there, and code had become complex. There was feedback on the app not always starting up properly. Sometimes the screen would just stay white, like in this picture. Developers agreed that the startup process is the culprit. This was one of the first tasks I started to look at, and it indeed was complex. It took me a couple of days to grasp what was going on. There were so many steps, which each could lead to some hard to handle error cases. I identified over 15 API calls being made, which contributed to the complexity. The app was using Redux for state management and Redux sagas for async operations. So Redux was heavily involved trying to keep local and remote data in sync. It was clear that we wanted to try and simplify the startup process, but how? This is when I remembered GraphQL. I hadn't used GraphQL for a real project yet, but I had attended GraphQL Finland conference, been reading about it and playing around with it. This gave an idea that maybe, just maybe, GraphQL could help solve the startup process and at the same time help the app's state management and data syncing elsewhere too. There will be roughly 5 topics I covered today, which go through the lessons learned during this migration. First, how the proof of concept was built and basic usage of Apollo in a React project. Second, how we ended up loading article data using local resolvers. Third, an example of how to use type policies with Apollo cache. Fourth, local state management using React variables. And fifth, how to debug and test React components using Apollo. So let's start with the proof of concept. The change to using GraphQL would be a pretty big change to the application. So we didn't want to be too hasty with the decision to go through with it. Initially, I decided to make a proof of concept for just a startup, how it could work using GraphQL. My goal was to make it simpler with fewer API calls. The proof of concept was implemented as a separate React Native TypeScript app with then brand new Apollo Client 3 early beta release. For backend, Apollo Server 3 was used to do a quick and dirty GraphQL gateway. We had our current architecture that needed to keep working. So the gateway was built as a separate service, which behind the scenes used Apollo data REST source to query the REST APIs in place. This made it quick to test out GraphQL with real APIs without breaking changes to the current setup. I worked hard on getting the proof of concept ready within a week to show that it would be a viable solution and something worthy of investing more time as a real solution for us. The finished proof of concept had a much simpler and working startup flow, although not all real apps functions. Being able to browse the list of articles and even read some of them. Much of this was possible due to the nature of GraphQL and Apollo client. In the end, there were 1 or 2 API calls. One mutation to register the device for the first time. Second, to receive the articles and user info. Preferences query is able to combine multiple separate REST API calls. Queries are your typical way to get data from the backend. Mutations are used to modify the backend data. So how do we use these GraphQL operations using Apollo client? There are 3 very handy hooks available. UseQuery is the basic hook to make queries to receive data. It gives you back data, error, and loading objects, which can be used to then populate the UI however wanted. UseQuery is run right away when the component is mounted. UseLazyQuery also runs queries, but not right away. Instead, get back a function that can be called to make the query to be run. This is useful when you need to run the query only as a reaction to something. For example, when a user presses a button or when another async call is returned. UseMutation is used to update backend data, and similarly to UseLazyQuery, gives you a function to run. That function will take the variables the operation uses as an argument. For example, registering the user, we pass device token and user ID to the registered device function. Here is a small example app illustrating how we can use the Apollo hooks. On the left-hand side, we have a Hello EU query. We have a Hello React component that uses the query through UseLazyQuery. This is so that we can make the query only when the user presses the button. After we have the data, it is displayed to the user as shown on the right screenshot. Now, not everything was as easy as using the hooks. First challenge was persisting the cache. We wanted to save the user info so we wouldn't do the registering mutation again next time the app is started. This meant we wanted to keep the user ID and device token persisted. Apollo client can handle local state management as well, so it was used for the user info and using cache persistence to save it. Apollo client itself doesn't have a persistence built in, but there is a Apollo Cache persist library. It doesn't support version 3 out of the box, at least not yet. So for the proof of concept, a workaround was used. We try to read the user info inside the cache, and if there is an error, meaning persistent data doesn't exist, we write the initial data ourselves there. Also, we add on reset store callback to write the initial data there as well on reset. This way the data is always initialized properly. This does add an extra async step to the setup, which is an awkward inside the React component and leads to a bit of a complex use effect hook solution. I have been talking to Apollo client developers, and it sounds like rethinking persistence is on the roadmap, and if it was baked into the library, there would be a way to get the initial data setup much cleaner done. Article data has content, which is represented by an array of content blocks. Example blocks would be heading block, text block, or image block. You can see how the union is defined in the backend. This did not work out of the box on the Apollo client side, but required configuration. Also, Apollo Client 3 has changed how the configuration happens. Now one can define possible types within in-memory cache and give the type names that some types can be. Here we do it manually for content blocks, but if you would have a lot of possible types needed to be defined, Apollo documentation shows a way to generate the possible types from your schema automatically as well. Next, when querying content, we cannot query fields directly, but we need to have split the inside using fragments. Here they are inlined. This is needed as not all the fields are available in all the possible types. For example, level is only available on heading block and caption on image block. One thing to make the development much more fun and easier is the GraphQL playground, which Apollo server has built in for development builds. It allows you to easily make GraphQL operations against your GraphQL endpoint. My typical workflow involves trying out the queries first in the playground, and once I am satisfied, I will copy them over to the code. It was also priceless in developing the proof of concept backend to test changes fast. I find this to be an excellent development experience and real boon for using GraphQL in my projects. After proof of concept and getting a go-ahead, we needed to consider the backend solution. It was decided to create a new backend GraphQL API. Instead of Apollo server, which was used for the proof of concept, a JVM-based GraphQL server was chosen for the interop with the rest of the backend. We also made the decision not to make article data accessible through GraphQL API, but keep it as a separate REST API. This was a highly optimized and cached endpoint, which we needed to work flawlessly. Getting article data to Apollo server with Apollo data sources worked really well, but since we needed to get them now on the client side, we had to do it differently. We still wanted to keep GraphQL as the abstraction and not have components make REST API calls. We decided to try to accomplish this by using local resolvers, which allow you to have queries in the field that are not represented in your remote GraphQL schema, but are only on the client side and resolved by the local resolver. First, we do the REST API call on the client within a local resolver to fetch the articles data using Axios. Second, we enforce the data, and third, we write the resulting data manually to the cache. Why the need to enforce the data fields? At first, this worked great without it, returning simple dummy data. But when trying with real articles data, nothing came through and there were no errors. Apollo was silently dropping the response as it didn't contain all the fields requested. Articles data has lots of fields that are optional and they might be missing completely from the response. We needed a way to make sure those would be at the very least present with the value of null. In addition, we wanted to add the __ type name to the response objects. Apollo uses the type name to know the types so that it is able to normalize and properly match the objects to the right types. For this, we build a function called enforce response schema, which takes the data and a response schema, where we can specify all the fields the response should have and their default values if they are missing. For example, here we have the schema for image block, making sure that caption is always there with the default value of null, etc. How does the enforcement happen? It is a bit convoluted, so the code is not easy to show here, but it is using JavaScript proxies under the hood. Overall, we got some good learnings from loading the articles using local resolvers. Data enforcing was trickier than it first looked. Knowing that we know now, we might not have gone this route. Also, now that Apollo Client 3 is out, local resolvers are officially deprecated, which makes this solution not best for the long term. Field policies and reactive variables are Apollo Client 3's new way to do local state, and more on this later. There is, however, a difference how they behave compared to local resolvers. They are not able to return promises, so they cannot do async operations the same way than with local resolvers. This leads me to think using Apollo Link REST, a library meant to query REST endpoints within Apollo queries, or building a custom Apollo link would be most likely the proper solution. But since we now have a working solution, we haven't had the time to check these options yet, but we might later. Third, let's look at the Apollo's cache and how we can customize querying from the cache with type policies. Apollo has a very powerful cache where it stores the data that it has received. It uses data normalization to optimize reading and updating the graph as your application changes state. Here you can see part of our cache after the articles query has finished. We have the query and then articles objects which contain data on the articles. We need this extra structure in our case because article query has concepts and extra data which we need to access as well from article. This led to an interesting challenge. After we have fetched the articles and they are in cache, when the user goes to read a specific article, we'd like it to be read from the cache. We can make the query on the left-hand side, but if read the article object directly, we don't get the article query extra data, concepts and extra. We actually want to return the corresponding article query response instead of article. Luckily, type policies are quite flexible, and there was a pretty nice solution to solve this challenge. We can customize the ID value for article query using the article ID. You can see this done on the right-hand side by defining key fields for article query. It has a special square bracket syntax in order to be able to refer to its children's values. This we need since we want to use the article's ID as the key value for article query, the parent field. After we have done this, we can refer to it in our query type policy for article. We receive existing data, arguments, and to reference function. We return existing data if it exists. Otherwise, we return reference to the correct article type entry in the cache in order to get that concepts and extra data. Okay, as I mentioned before about local state management, Apollo Client 3 introduced a new way of doing local state management other than local resolvers. Reactive variables became available during the beta phase and looked like a really interesting improvement, so we wanted to try them out. It helps me a lot to divide cache in 3 different types. There is remote state, which is coming from the backend. Apollo queries are a good match to handle those. This way, we are not required to manually try to keep the data in sync with the backend, like with Redux. Then there is the local state, which is a state that should be available in many screens of your app, but something you don't want to store to the backend. Reactive variables are good with this kind of data. Last, there is component state, which is the state only needed within the React component. These are best handled with React hooks and don't need a separate state management system, in my opinion. So, what are reactive variables for Apollo? They allow you to store local state outside of the Apollo client cache. And because of that, they can store data of any type, not just something defined for the cache. They are also available for you outside of interacting with the cache. But the huge upside is that many or any GraphQL query that depends on a reactive variable will be automatically updated when the value of that reactive variable changes. I find this to be a perfect fit for React application, bringing ergonomics for the local state, but keeping the reactivity of React. Creating variables or reactive variables is easy. Import make_var from Apollo client and use it to create your own reactive variables. Make_var takes the initial value as an argument. Important to notice that the return value is not a variable, but a function. This allows you to read and modify the value afterwards. To read the value of a reactive variable, call the function returned by make_var without any arguments. This returns the current value. It is important to know that this return value itself is not reactive, but whatever the value was when this function call happened. For this reason, in React components, the best way to get the value is by querying it with the @client directive. Cache then needs to have the field read function defined in type policies, which will return the value of the reactive variable, like user_var in the example. Now, if the user is updated anywhere, Apollo will trigger an update to the getUser query in the component, which will update the component with the updated value, and the UI is kept up to date. To update a reactive variable, again call the function returned by make_var, but this time pass the updated value as an argument. Here, for example, we update the user to have an ID of Juha and accepted privacy policy version of 3. So after you have specified the read function for a field in cache policies, you are good to go and start using the values inside React components. Typical use case to display a reactive variable in a React component looks something like this. First, you make the query. Notice the @client directive for the user, which tells Apollo to only look on the local state side and not send that part over to the backend. Second, define the useQuery hook, passing the query to it. It returns then an object with data which has the user info. Third, now you can use the data to run some logic and render the value to the UI. Here we have a text component displaying the accepted privacy policy version. And that's it. Now this is a fully reactive, so no matter where or by what the accepted privacy policy version gets updated, this component is sure to re-render and display the correct value. If you end up using the same reactive variable in multiple components, it is easy to extract that query and use query as a custom hook. One thing we noticed is that we needed to manually handle the persistence of reactive variables. Reactive variables are not stored within Apollo's cache, so even if you persist your Apollo cache, reactive variables won't be persisted. Our current workaround is to update the latest value to async storage every time the value gets updated. For example, here we update the accepted privacy policy. We make a call to store user, which is a function that handles saving the value to async storage. When the application is starting up, we manually go and fetch those keys and call the reactive variables with the persisted values, rehydrating the variables. This is an area where, in my opinion, Apollo could work on to make it easier and have a built-in way to specify that you want a reactive variable to be persisted. Luckily, from some talks with the Apollo developers, it does sound like they acknowledge this too, so I'm hopeful this will happen in the future. So one very important part for the developers is how they can debug their code, and GraphQL is no different. Apollo provides developers tools for the client, but unfortunately they are not directly compatible with React Native Chrome debugging. For React, Chrome DevTools will pick up Apollo and have the tab shown for it. This doesn't work with React Native as the tab never appears. Luckily, React Native Debug, a dedicated debugging desktop app which contains the Chrome DevTools as well, has built-in support, and the Apollo DevTools will be shown in the tab. During the version 3 beta, this was broken for a while, but since the final release, it seems to be working. Here you can access all the features that the DevTools provide, which include GraphQL, which is the GraphQL playground, where you can run GraphQL operations and see the output. Queries and mutations, see what queries are being executed in your app and which components are running them. And cache, see what is inside your normalized Apollo cache, which is now showing the articles in here. These are very useful for debugging purposes, especially seeing the state of the cache has helped out many times. After React Native 0.62, many prefer debugging React Native apps with Flipper, which is an excellent debugging tool provided by Facebook. I got into thinking whether it would be possible to run Apollo Client DevTools as a Flipper plugin. I posted it as a feature request and many seemed excited for this to happen. The DevTools are now in the process of being remade, so it might be a good idea to wait for that to be finished before working on the plugin. But I wanted to try it out anyways already, so I forked the DevTools, and after a while of tinkering with it, there is now an alpha version that has the cache store tab working, which can be seen here. If you are interested in getting the rest to work as well, feel free to come and contribute. Testing is also an important area to consider, and it was pleasant to see this was considered well from Apollo. They provide a mock provider component, which we use in conjunction with React testing library's React Native version. Mock providers mocks are request result pairs. So first we specify what the request should look like, and if that matches, mock provider will give back the result as a response. Once we have a mock provider, we can create a wrapper that can be used for the components that we want to test. For a simple example, here we have a React hook which has a GraphQL operation inside. We use React Hooks testing library to render the useLogin hook, wrap it in our wrapper that provides the mock response. This allows us to assert what the response from the operation should be. There was one gotcha that took some time to realize. Mocks given to mock provider didn't work for local resolvers. This is related to the issue that if the mock is not working, there was no warning or error to see what was wrong. Maybe some variable doesn't match 100%, not sure. So it was very hard to debug why the mock was not working. Luckily, it is possible to also pass resolvers to the mock provider with the resolvers props. This approach works with local resolvers, but all in all, I would have preferred a unified way and better debuggability when it comes to testing Apollo operations. Okay, we are coming to the end of our journey together. The application itself is not all done yet and is still under active development. But so far we have been quite happy with using Apollo and GraphQL for handling remote and local state in the Uutisvahti app. Here is a screenshot of the application right now. For the outcome, I want to highlight 3 areas especially. API interface became super clear. GraphQL schema coupled with TypeScript, you will know exactly what data you are receiving and what input variables are required for a mutation. You can also easily test these out on GraphQL playground beforehand. There are no issues of over or under fetching, and we are able to reduce the amount of API calls in the startup of Yle Uutisvahti from 15 API calls to just 1. Compared to our old state management solution using Redux, which had remote state, local state, and component state all bundled in the Redux store, there are now much better boundaries, and each kind of state is easier to work with and test for. This leads to the third point. The app logic has been greatly simplified, making things that were very complex and sometimes had hard to debug errors now easy to understand and reason about. To our surprise, we have noticed even some of the users wanting to already use the beta app, even though it is missing many of the features still, just because it is so stable. Thank you for your time listening to me today. I'm happy to discuss more in detail our experience in GraphQLifying React Native app with you. You can get in touch with me at plrdev on Twitter or GitHub. Thanks.
thank you for this talk. Now, I have a sort of special sympathy to talks like that talk about real life challenges. I think that it is always great to showcase the real work and the real problems that we are facing every day. So always excited about journeys like that. Anyway, let's move on to our last speaker, Gant, a friend of mine, great MC, currently working at Infinite Red as a Chief Innovation Officer, so he also has now a fancy director title like I do, but worry not, we're still coding, so you're in for a technical talk that Gant has prepared for us. Now, if you remember, Gant spoke at ReactNative EU last year, not 2 years ago, where he did a talk about Nicolas Cage and building a VR/AR applications. He was looking for Nicolas Cage from within the ReactNative EU audience, and I think he succeeded, so that's great. Anyway, when he sent in a talk titled "Who Said It?", I got really curious, and I have no idea what is it going to be about, but I'm really curious about it. I'm sure it's going to be great. So let's welcome Gant on our ReactNative EU virtual stage and see what is it that he prepared for us today.
Hey everybody, it's your good friend Gant Laborde coming straight from the Mad Science Lab, and I am very happy to be presenting to you today. We'll be taking a look at a really cool project, I believe, and we'll dig into some pretty awesome React Native code. So with that, let's get started. The name of the talk is Who Said It? So who's this guy is actually what you're really asking, right? Who the hell is he? And if you don't know who I am, you must be new to React Native EU or something like that, but that's okay. I am a React Native developer, core contributor, fan of open source, and I really do love titles after my name, which is ridiculous. I have quite a few of them. If you know any other place where I can get some more cool titles after my name, let me know. But I'm not going to bore you with those here. I'll just kind of say I like to be I'd like to say I'm a mad scientist, but I am really just a nerd. And that's what this means to me. I am going to nerd out really hard on React Native, and hopefully we all get to enjoy that together. And I just want to say, like, that being a part of this has been a place that I have habitually come to absolutely nerd out. This is a great place to be a part of React Native. It's React Native EU. Actually, fun fact, I don't know if you know this because now, React Native is getting so mature, is I was the first speaker at React Native EU in 2017. And then I think I opened up the first talk for the second day in 2018. So big fan of this conference, big fan of CallStack. Everybody who's comes together and make this experience fantastic. It's a really fun place to learn about new technology, and I always want to bring something cool and interesting. And in 2017, I brought it. And in 2018, I brought it. In 2019, I had a daughter, so Jamin Holmgren came in and he brought it. So here I am speaking in 2020, and you're saying, all right, Gant, what amazing new thing have you cooked up? What do you have here? And I hate to pull a React 17 on you, but I don't have anything groundbreaking to show. And that's what can you do? I've already put machine learning into React Native. We've built some really cool stuff, and I'm sure there's plenty of talks where people will be talking about cool new things that you can do. And I decided to go a little bit of a different angle this time, because that sort of hype train can't keep going, right? You have to find some point to stabilize. So I'm going to say specifically, we can make something new. And that's my goal. I'm going to make something with you. And I think that still counts as something new. As a matter of fact, to quote from The Art of War, which gets, I know, overquoted all the time. I will say, there are not more than 5 primary colors. Yet in combination, these produce more hues that can ever be seen. And Sun Tzu said that, and I think that by taking all the cool things we've done already in React Native, I can create something that is cool, rewarding, and new, and we can kind of share that here. So I think I said this in 2017. Like, why did you get into mobile? Why did I get into mobile? Why did we want to start making mobile applications? And I would say that mobile applications go to people and they help them connect. It helps you share that feeling. And I think that this is the power that you get from a mobile application. You can't really get from anything else. You need to have this sort of edge device that can connect people in a way that normally would take a lot of work, or would take a person, or would take some kind of complicated procedure. And instead, we can have meetups and groups and people delivering food straight to your door during a pandemic. It's about sharing, and it's a little bit about sharing, I think, a feeling. So I did some searching, and there's this really cool feeling that we get to share at Infinite Red. And I said, this is a cool thing. I want to share it with the world. And what it is, it's a game that we play. It's called Who Said It? And we play this game, and it's quite simple. You put in quotes completely out of context of people around you, and then everybody has to guess who said whatever it is. So let's just kind of do like a fun little match real quick, right? I think you all you're familiar with the React players, so these will be from famous React people. Just kidding, I will ban you. Now, who said that? Doesn't sound like him, but that's one of Dan Abramov's most famous tweets, which is pretty funny to me. Doesn't sound like him at all, but he says some stuff on Twitter that is totally left field sometime, and I love it. Okay, let's play again. Hanging a TV is basically like centering a div in real life. So this one's like remarkably clean, considering that this is a quote from, Ken Wheeler. So, yeah, you wouldn't have guessed that one. And it's a little bit of fun. Like, it's a great quote. It needs to be immortalized. You can kind of put this together, and it's fun. Let's do a few more. Align items, justify content are the CSS equivalent of trying to plug in a USB. This one did really well. And of course, this is our good friend Yanni. So Yanni said this one. It's one of his most popular tweets, and a great quote for him. It's totally Yanni style. You should have gotten this one. If you've ever been to Yanni's talks, you know that's him. And then the last one here, I'll do Electron app in memory, 150 megabytes. Sure. A native app in memory is 0 megabytes because you never shipped it, which is unfortunately very true. And so that quote's from Jamin Holmgren. You get the idea. Like, this is kind of fun. Now, imagine you went away with your team for a weekend and you decided to go ahead and just record some of these things. Like, we had an all-team retreat in 2017. And so we just made a Slack channel with a few of us having access to it, where we put in quotes that we heard from other team members. And on the last night, we stood up and we did this, like, guess who said it game. And it was a blast. So we've been playing this game, honestly, since 2017 with our company. And we really enjoy it. But there's a gotcha with this. Because it's in a Slack room, if I'm one of the people who adds quotes, I get to see all the quotes as they come in. So I kind of don't get to play. I mean, I get to see, the answers when they come in. So whenever anybody asks about this, I already know the answers. So we kind of do this a little bit for ourselves, but a little bit for the team. And it's like, okay, sure, it's fine enough. But there's another problem. And this is the complication of a workflow, right? The developers in your head are starting to like say, okay, this could be solved. And so here's another problem. We're hanging out. It's the team. If I'm entering quotes, it's just the people that I'm around at the times that I'm around them that I get to go ahead and enter their quotes in. So if there's an entire clique that I'm not around and we don't have anybody entering it, those quotes don't happen. By the way, the sun was in my eyes for this photo in a ridiculous amount. I get it. Y'all can open your eyes in the sun, and for some reason I can't. I'm a programmer. I can't do it. I'm sorry. Okay? Let's just let it go. Just let it go. So what we have here is straight up, I can't enter these quotes from clicks that I'm not a part of. So then that's another problem with the Slack room. And then if we add people to the Slack room, then that's more people can see the quotes. And so this starts to get problematic. And what we know is that software is, like I said, it connects us. It helps us create these sort of like structures. And I think like you probably felt it as well. This isn't complicated, Gant. You can do this. This is no problem for it. So why don't you just shut up and build it? Just go build exactly that app. So you and get into playing, what are you going to do? Mess with some GraphQL and some React Native? Like, this is going to be fun. And then you could share it with the world, right? And then everybody can play Who Said It, just like we've been playing for years. And that comes in with there's this problem of scope that us as mobile developers have. Because you might see this like Gant, you could build it. It's just a glorified to-do list. And every single app and every single state management system basically shows you how to do this. But you would be wrong. And so like, I think that this is part of the adventure of like professionalism in this kind of aspect, is that you can't just, in the web world, you can kind of just ship anything. But mobile devs have a much more complicated path going forward. And you can look at this and say, okay, well, I mean, there's a lot of problems with sort of like making public lists, right? Public chat rooms and public anything. First of all, everybody is going to be able to see everybody else's lists and information. It'll be over flooded. It's not like I can post some secret URL on the internet and then just call it. And it's not like you want people going and reading your company's messages to one another or their quotes, right? So how can I in good faith say, oh, don't worry, let's go ahead and do that and just kind of like make this glorified to-do list? And that's the cool thing about it, is we are held to a higher standard, so we have to build cooler stuff and we have to still see it through. So I tell you, React Native EU, that this is not a novel game. This is not a novel problem. And this is not a novel process that I had to go through. But out of all those three things combined together, we do get some kind of novel, cool project. And so I got to actually build this entire project. And I built it specifically for my team to share to the rest of the world, and to build for this particular conference. So let's take a look at how that problem got solved. Now, if you're watching this on recording, I challenge you, pause for a moment and come up with your own solution on how you would take that note. Like you have a way to play Who Said This quote out of context with your team. And then how would you build it? And I would love to know in the React Native EU YouTube comments or on Twitter or anywhere, what's the difference between what I did and what you would have done? Do you like what I did? Do you think I could have done it better? I want to know these things. These are the discussions. This is what conferences are meant to do. And I know we're virtual, but that means you have to put out the extra effort. You can't be a lurker. Come out and let me know. Okay, so let's take a look at what I came up with, right? So this is the Who Said It app. Yeah, I went with a comic book theme, and I want to say super, super awesome. Kudos. I'll go into how the designs kind of all work together, but this is UI Kitten down to the metal. I am not a designer. I said, UI Kitten, can you make my stuff look okay? And it said, yes, I will absolutely do that. So I can say here, I want to check quotes. So I could say check quotes, and then I get all the quotes from my team. I could check this cool stuff out. And then I could say, I want to search some quotes here. So I'm looking here. I could say, oh, I want to check out a quote and I want to see some stuff from Ryan or whoever. Okay, let's see Kevin quotes. And so I can see who entered that quote in, what it contains. I could even check by the date. And so I can kind of search here. And so Kevin's got a couple of quotes that are really fun. Nice, everything is wrong. And when life gives you pie, you make pie-monade. And so he said this. And so if I kind of click into here, I can see the quote and get the answer, by the way, while they're all randomized. And I can see who added it and when they added it. So that's pretty cool. And we can see that this is a filtered version of this. If I clear this out, I get the full list again. And then I can, of course, hit the randomize button up here at the top left and get everything all cool and random. So I've got that set up so I can actually read quotes and stand up in front of the team, either at all team or virtually, and then have some quotes to read. We can play the game before like an all team meeting or all hands. And then I can easily add quotes as well. So if I go in here, I say I want to add a particular quote, then I can just type in what they say, optionally like the context of it, and then tag them. And this is the autocomplete. Thank you so much, UI Kitten. So if I say Todd did this, oh, look, there it is. Got Todd right there. It's got some features in here where I can add people who aren't even in the system yet. And then it adds a brand new author as we go along. So that's pretty cool. So check quotes, add quotes. Gant, how did you solve the problem of stopping people from seeing each other's quotes, right? Well, that's easy enough. You can create a group. So over here, the group is just like a random code. So we could create a group called, Twitter quotes or something like that. And then we could all hop in there. And that'll be the quotes that people can add that are Twitter quotes. And then I'll be an admin because I've created this group. And that's fun enough. And then you say to yourself, by the way, I'm not named Jed. I don't know why I'm just set as Jed. So your company can create their own group. And this is basically like a password, stopping people from, you'd have to guess the group names just to kind of go over there. So you could say like Fun Family Getaway 2020, and that's your group code. As long as everybody who joins types in that group code, all of your quotes will be together just particularly there. And then there's this last aspect of security that we needed to worry about, right? Why I don't want you being able to come in and add quotes to Infinite Red, right? This is just our group. This is people who work at Infinite Red. So my email address is gant@infinite.red. So I simply lock this in so that I get this magic button right here. And when I click that, I am added to the Infinite Red group. I'm not Jed, I'm Gant. And you can't type in infinite.red. There's just no way for you to kind of get through here. And then I can say, okay, I'm good. I'm joining the group infinite.red. And anybody who has that email address can have it. So callstack.io, you can create a group for everybody there, and you will have a special button. It's callstack.io, and no one else will be able to join that. You will simply be blocked off, and you can do that. Then I can go away with the family for the weekend, type in, Nachos 2020, and we can kind of have a weekend of quotes here and have fun. So I'll just join Nachos 2020 real quick and add a bunch of quotes to that. I'm the admin now, and I'm set. So this allows you to play Who Said It, and it allows you to go ahead and add all these fun quotes, and everybody can add it. Doesn't matter who you are at the company. You can just log in and add it, and it sticks your name next to as the creditor of the person who heard it. It's a lot of fun. And this kind of design is made possible because this was easy to make. And I can tell you, this would not have been easy to make just in 2017, 2018. So many amazing tools have come out that allow us to kind of do this. So I want to definitely get into the code and kind of mention a little bit of exactly how this works. But the concept of just kind of throwing this together for my team and your team and everybody, just it should be in the App Store by the time this airs. So feel free to download it. That's the cool thing that kind of comes from all this. So, all right, built an app, just kind of get all set up there, build all these fun screens and add stuff out there. It was really cool. So how does something like this actually come together? Like, how do you build this just for a conference talk? And it's really easy. I'd say, like I already mentioned to them, kudos to UIKitten. Now, I wanted to try Paper. It was made by CallStack. It's amazing. And React Native Paper is such a cool tool, but I wanted to try something a little bit different on this one. And I wanted it to flavor my design a little bit. And I wanted it to kind of take care of a few things. So I tried UIKitten this time. I would say anything, as long as you're trying to cut the corner of design, throw either of those out there. But this time I went with UIKitten for this, and it was a fantastic experience. And then how do I manage these complex user permissions? I mean, think about this. You can't see a group that you haven't joined. You can't join certain domains. You can't do all this other stuff. I'm accessing GraphQL. You might say that, Gant, you spent more time on the back end for this than you ever spent doing the actual app. And the answer is like, no, actually it's pretty easy. I used Amplify. Sorry about the design there. Flew off to the right side. That says AWS Amplify. I've changed the proportionalities for this talk. But Amplify gave me the ability to put login with 0 effort, to put GraphQL with 0 effort, to enable like protections with Cognito with 0 effort. And it did this other thing. So like when I came to the part where I wanted no one to be able to join my domain and no one to be able to join that domain, I was able to do dynamic permissions under Amplify. And I was able to quickly build a Lambda function on there, and set it up so that way, like my app actually is moving people from one group to another, and I don't have to run any kind of server. Now, all this stuff is done with AWS. So that's a really awesome feature that I'll say. It's like one of the key aspects that kind of attracted me to this is that I could do the entire project with Amplify quite easily. So, let's take a look at some code, right? Everybody wants to look at a little bit of React code, see what UIKitten and Amplify actually look like when we're implementing it. I'm going to give you a big warning here. This is code for a conference and a release of an app. Expect dirty code. I apologize, but hey, it worked fantastic. And now I can go back and clean it up. But as the time for sending this video in is running nigh, I need to hit that deadline. So apologies if the code does not look like our normal quality. So let's pull up this code here and let's take a look. So, all right, I know it's always a bit of a shock jumping from this straight into the code. So we're taking a look at the index.js, the basic entry point of the entire thing. And you can see that I have the Amplify set up, and I just say Amplify configure. And this accesses my AWS exports that get spit out. And that kind of gets me the background access to all my AWS services that I sign up for. So I have some crash handlers here, just to make sure that I actually give them a message if somehow you crash my app. This is in my blog post, React Native Final Steps. Don't ship an app without telling someone nicely what the hell is going on. And so go ahead and right here, just go ahead and amplify up the project and then hop straight into the app, which is great. And then here inside the app, it's starting to look very much like the default UIKitten setup. So UIKitten has some really cool stuff, and it has a theming engine built through it. And the cool thing is, you might see here, I've got this custom theme.json. Now, if you go through the EVA design process, you can go to the website, pick your primary colors, and have it actually space this stuff out. And it spits out this JSON file, which you can then bring into your app and set up for your entire theme. So what's really cool is if you've never used UIKitten before, you can say, I'm going to have a light theme or a dark theme. As you can see, I have a dark theme. You can use a sketch file to like lay out all your designs and get them done. And then you can spit out JSON, which will help make sure all your colors are set up appropriately and your primaries and everything. And then you just feed that directly into the top level of the provider there. This is a provider, but this is the application provider. And then I just set up the theme. So I have the EVA dark plus a couple of modifications sort of spread into that operation and merged. That's it. That gives me this really cool sort of look and feel straight out of UIKitten, which I really enjoyed. And if tomorrow I think that my danger button is the wrong color, I can just go back to the website, modify the stuff, and export a new JSON file. That's pretty cool. So this custom theme stuff of the UIKitten was very fun. It cut a lot of time out of making this a project. Thank you so much for having this kind of cool stuff. And it allows me to build really cool stuff really fast. And so we're taking a look here, and I've got just things set up, and we hop straight into our navigation. And I've got all my screens laid out. One of the things you'll notice here, I think you'll see, is that I have the main one is the home screen. And then to make it so that you have to log in, this was Amplify magic. I didn't have to do a lot of stuff here. So for the home screen, I just built the home screen as I wanted to. Yes, I know. It's a lot of inline styles. Shh. I told you I was building this quickly, right? But then I just wrap the whole home screen with Authenticator. And with Authenticator, as we take a look here, comes right out of AWS Amplify React Native. And then now you have to log in order to move on. You have for access on this screen. So the cool thing that I get here is that now with Authenticator, I can configure it up a little bit, and I can fully customize it. But think about what your normal login process includes. You have to have reset password, email verification to make sure that they actually have that email, sending codes, sending text messages, forgot password, and all these other kinds of things. I didn't have to write any of that. That's 100% already done. And all I had to do was say yep, for the username, it's your email. And then I don't want your phone number. Do not send me your phone number. Hide that out. And then I was able to just pass along my own sort of theming on that, some custom styles to make it the colors of my app. That was it. And then now I have login for this process. So that was a really big boost into speed. If you haven't seen any of the talks on Amplify, adding authentication quickly, if you need to go ahead and do a proof of concept, if you're looking to go ahead and ship something straight out with you need authentication, what a great feature. So now I've already got the app with login, and I've already got the app with awesome, cool styles. Very easy. So my to-do list app is just, it's getting a little bit more complicated, but it's not that much difficulty. And then when you go to screens like adding something, now I'm able to just go ahead and use Amplify again. And so I use the Amplify API. And so the Amplify API, let's see here. I am, it's lots of animations and fun stuff here. Let's go to something simple. Create the quote, right? I'm sending you this quote. Well, I say API GraphQL, and then the query I'm trying to tell it that I want to send is the create quote. Now, did I write create quote? No, that got generated for me. So I get to just send it the quote, the information, the org name, send it over. But this GraphQL, if you take a look, we automatically generate mutations, queries, and subscriptions based off of our GraphQL schema, which actually is a little bit up there. I'll show you. But this create quote comes out of the box. If you want to see create quote, I'm sorry, I'm totally naming it wrong. Create quote, where's that coming from? Mutations, of course, it's creation. See, it's idiot proof. Create quote. Yeah, so of course, yeah, this is exactly where that would be. And I didn't write a line of this whole file, actually. I didn't write any of that. That all comes out of Amplify. If you want to know more about Amplify, if you think that maybe, Gant, you should build a course on something like that, let me know. And then this all kind of ties back. Specifically, if we take a look, we have Amplify. We could take a look here. We could see the back end. And so I'm kind of running out of time, but you could see that I have my API calls, my auth, the function that I told you that I wrote. All this stuff's available. It kind of comes through there, and it's inside your code base to set you up as well. So in a very short amount of time, using some fantastic services and using some really good know-how of how to wield React Native, this project came together and was kind of set. So if you want to see more code, let me know. I can go into plenty more detail with you on Twitter or other places. If there's any aspect of the app you download, you have any problem, or you want to know how I did it, I will tell you. I will tell you all of this stuff. So that's how I built an app just for this conference and just for everybody to have a lot of fun. Like I said a little while ago, there were some final steps that I kind of went through. I think it was really cool. Definitely check out that blog post. It was based on the final steps I went through before I released this to the App Store and the Google Play Store. So look for React Native final steps. And I really do hope that you enjoy the app. Subtitle there because, I have no other thing else to say. It's just enjoy the app, right? But thank you so much to everybody who helps make these things possible. Number one, Infinite Red for giving me the ideas, the time, the energy to build these cool things. React Native U for giving me the place to show it and share it with you all. I hope that we all there's no charge in this setup. And if this is in the App Store by the time this talk happens, just enjoy it. It's super cool stuff, all built with React Native. And this is about connecting people. And then kudos to the other people who help us connect. Specifically, UI Kitten, which I used for this design and made it me as a developer be able to make something that doesn't look absolutely atrocious. And then, of course, thanks so much to Amplify. I think Amplify is really cool. That was a ton of back-end work that I skipped just to go ahead and build something really fun. Last but not least, you for listening to my talk, for being interested in this. And especially preemptively, I'm going to say, for asking questions. So thank you so much, React Native EU. I miss you all. I wish I were there. I wish that we all were there. I wish I was going to an after party with you all in person so we could talk about stuff and I could overhear your quotes and then put them in my app. But until next year, this is Gant Laborde. See you later.
Thank you, Gant. Always top-notch performance, great emceeing and speaker skills. I have somebody to chase. So let's move on to the break. That wraps up the data management and GraphQL block. Now it's time for a break. And I was thinking it was about to be a lunch break, but it tells me that we're gonna have 15 minutes. So let me ask Barbara.
Minutes, but if you want.
No. I'm not hungry yet. I was just thinking that. Oh, so did we have lunch break already? On the second day? No. Oh.
One są po 15 minut.
Okay. So sorry for those of you that were watching us live yesterday. And I hope that I'm talking to everybody now. I told you that we were going to have lunch break and it turned out to be just 15 minutes. I thought we were about to have like 45, so sorry if you didn't finish your meal in 15 minutes. That's not what I wanted to tell you. So anyway, sorry for this little misunderstanding, but all I want to say now is that we have 15 minutes of break time now. So quick time for coffee, some food, meals, and of course, Twitter, React Native EU hashtag, and Discord channel. Don't forget about these two. We are waiting for you there. So enjoy the break and see you here back in 15 minutes. This conference is brought to you by ColdStack, the React and React Native development experts. Meet us at coldstack.com.
Hello.
Wake up in Wrocław, get up and get at 'em. React Native EU is on and it's happening. Check in to check up on all of the latest news and strategy. Man, it's kind of the greatest.
Welcome to React Native EU 2019.
Keynotes that unlock a new world of insight. Lightning talks this cutting edge? It really seems so right. Networking with everyone in the React Native community, from the thinkers to the linkers, we're all here in unity. Q&As that dive deep into code DNA, and it's all covered here in only 2 days?
Especially when it comes to trouble.
After the last session, we're gonna party, okay? Food, drinks with good vibes and dope karaoke. High fives all around, it was good to be here. Can't wait till the next one. We'll see you next year. Calling all builders and tinkers, the doers and linkers, the ones who create it from scratch and the ones who code a clean patch. The code ninjas, the toolers, the thinkers, and don't forget the seasoned drinkers. Your open source lovers, your time tracking haters, the JavaScript junkies, and the wild bug wranglers. Your community is here and it's waiting for you. It's the first of its kind and it's called ReactNative EU. Core contributors and insights and networking and knowledge, all for ReactNative, it's in our language. Find us in Wrocław, Wrocław. Difficult to pronounce it. Your good vibes are here, go on and announce it.
Welcome back after the break. Welcome everybody again to our live stream. Welcome the new members that join us after the tweets that we did 15 minutes ago, and welcome everybody who's with us from the morning or maybe from the afternoon. So let's start with the last blog, which is showcases, and this blog is all about showing real life stories, something that I'm really excited about, as I told you before, and to show you how React Native can actually have an impact on real businesses and some real user scenarios. So let's move on to our first speaker in this blog, Alexander. And Alexander works at Horizon Alpha, and he is working on an application that has some crazy stats and crazy numbers behind it. Just to quote, the app has around 2 million downloads and around 300,000 active users, and they have 99.8% active sessions without any crash. So his talk is about the power of process automation and how that can help you deliver exciting and crazy and unbelievable numbers like that. So let's welcome Alexander onto our React Native AU virtual stage and learn about how we can make these numbers apply to our applications as well.
Hello and welcome here at React Native EU 2020 virtual conference, and welcome to my talk, Bringing the Power of Process Automation to React Native Development. I'm happy to be able to speak to you today, and I hope you'll find this topic as interesting and valuable as I do. But let me start with a little disclaimer first. So in my opinion, there is no right way how to do process automation, so I can't give you one. Even in our projects, we have very different levels of process automation. So it depends very much on the project itself, as well as the experience and preferences of the developer. So it's all about the question not to do things you don't need to do. And there are a lot of different ways in general and for React Native in specific. So this talk should be seen as one possible way or as some ideas, but not as the only right way. That said, I want to start with a real-world example. So this is a real project we have at our company, and it's the one I was mainly working on the last years. And I want to give you some insights in this project to give you an idea about the complexity of the project. It's a language learning app, so if you're interested in learning a new language, you should definitely check it out. It's called LearnMatch. The project started back in 2016 and was based on React Native right from the beginning. We have a 3-week release cycle with 30 to 40 issues for every release, which contains 2 to 3 larger features, as well as 1 or 2 A/B tests. So we A/B test a lot to improve user experience. The app is available in 36 languages, and it also has 50 plus different country configurations. So we're able to configure a lot inside the app, from UI to different courses, and we deploy these configurations to different countries. We also do have white label variants of the app. So we have a business version, we have versions for third-party customers, which all share the same code base. We also do have some parts of the app available as web version, and we do have to maintain a content management system for managing all the courses of the app. We have around 300,000 active users from all around the world at the moment, and nevertheless, the app is pretty stable, so we have a 99.8 sessions without crashes. The interesting thing is all the above is handled by a team of only 2 developers, and this is only possible due to the high level of automation we have in this project. And in this talk, I want to show you how we got there, what our tooling is, and what our processes are to be able to achieve this level of productivity and speed. But let me introduce myself very briefly. My name is Alexander Kuttig. I'm 32 years old. I founded my own software company in 2012. I'm a React Native developer since 2016. I made some small contributions on community projects like async storage and React Native Firebase, mainly because I needed the improvements for my own projects. And I'll try to write regularly on my Medium account about topics and problems I face in my daily business, as well as other cool things like the React Native EU conference here last year, which I attended and which I have written about. So if you like, you can follow me there. I'm working at my own company, Horizon Alpha. We are based in Munich. We are 25 people, mostly developers. We are shifting our focus more and more to React and React Native development, mostly with cloud-based backends, because most of our team has a cloud dev background, and that's where we're coming from. So we really like working with cloud-based solutions. We are working with all three big cloud providers, AWS, Google Cloud, and MS Azure. And when working with these cloud providers, especially on larger systems, you cannot get around the topic process automation. So process automation has a lot of benefits. So let's bring it to React Native development. Let's get back to our example project. So the start in 2016 was great. We developed a lot of features in very little time. But as the project got bigger and bigger, as the user base grew, as we had more and more configurations to test, we felt that our dev speed really slowed down a lot. And so we sat down and analyzed what we were doing all of the time. And this is what we discovered. We only had 30% of our time left for feature development. Over half of our time was used for testing, releasing new versions, and tracking bugs, which we got reported by our users. So we sat down with our customers and we had two options. The first one was to slow down the release cycle, so only release all 6 weeks, which we didn't want to do. So we tried to automate all steps which we don't have to do manually. So we wanted to automate a lot of review, testing, release, and bug tracking. And we did. So that's the 4 points I will talk about today. And yeah, we really saved a lot of time through the automation. I'll get back to this later. So to be able to automate, you basically need two things. First one is a good setup, and second one is a clearly defined process. So let's start with our setup. First thing to say, this illustration is simplified and does not contain all relationships or components, but it'll do for our case here. So the first thing you need is a single point of information. So this can be any list, tool, issue tracker, any service you're comfortable with. For us, it's a Jira board because everyone can integrate it nicely in his or her workflow. So if you like to get notified via email, you can do this via Jira. It also integrates into Slack, into Teams. It also has its own app, the Jira app. So the thing of the single point of information is when an issue is assigned to a developer, he has to be notified, and you have to have the guarantee that he reads this notification. So it's really cool to know that everyone can integrate it into his or her workflow as he or she likes. Second thing you need is a code management system. So we do use Bitbucket here because it integrates very nicely into Jira, but you also could use GitHub or GitLab. We do have some project where we use GitHub here and use GitHub issues as our single point of information. That also works very well. So feel free to use whatever you're comfortable with. Third system, and this is an interesting one, is a CI or CD system, continuous integration or continuous delivery system. This is basically a kind of service or server where your process automation pipeline runs. So where your steps will be completed. We do use Bitrise here because it comes with a lot of cool presets for React Native projects. It has a lot of steps based on Fastlane, which can be combined via drag and drop editor. So it's very easy to use for us, but there are a lot of other awesome tools out there. So just to mention a few, I have already worked with AWS Code Pipeline, which is a great tool. I have also worked with MS App Center, which works very fine here. So again, feel free to use whatever you like. Important thing here is the tool should be able to report back to your code management system as well as your single point of information, so that you have the information about your builds in the code management system and your single point of information. From there, we do fetch some configurations from our backend and bundle the release and deploy the release to the store. From there, the users download the app, and then the last of the 4 parts of our setup comes into play, the stability monitoring or bug tracking system. So we do use Bugsnag here because it has a very good React Native integration. We even can use Hermes source maps. For those of you who don't use source maps, you should definitely do. They are kind of back translating your compiled code to your decompiled code. So when we collect an error which occurred in our production version of our app, we see the exact line of JavaScript code where the error happened. So it's very easy for us to fix the error, and that's because of the source maps. So yeah, you should definitely use source maps. Important thing for the stability monitoring system, again, Bugsnag is just an example and the tool we use. You could also use Crashlytics or Sentry or Instabug or again MS App Center. Important thing is the system should be able to report information to your single point of information. So I'll talk more about this later. So this is our setup. Again, it's just an idea how to do this. And we use different providers in different projects. But I think it's a good idea to have at least these 4 components in the setup. So the single point of information, the code management system, the CI or CD system, and the stability monitoring. But the best setup is worth nothing without a good process. So you have to have a clearly defined process to be able to automate it. That's why it's called process automation. So our process is the following one, and I think that's very common. For every task or to-do or bug, we have its own issue. So for us, again, information is very important. I want to have a look at my single point of information and be able to say where the project stands and what's going on in the project. So for us, it's very important to have every task in its own issue. So coming to development, every issue gets its own branch. Every branch gets its own pull request, and every pull request gets reviewed. That's very important for code quality. And we do review automatically, and we do review manually. So again, it's very important for code quality. That's our process. Now let's start with the first automation. So again, information, very important for us. So we at first started to automate the moving of the issues. So every time an issue, a branch is created, we move the corresponding issue in the Jira board to the in progress column. So this is very easy, it saves some time because the developer doesn't have to do it by hand. When the developer opens a pull request, the automatic pull request review starts immediately. When the automatic review succeeds, we move the issue to the in review column and we inform the reviewer, the second developer who has to do the manual review. Again, Jira, very cool here because the second developer gets the information and the notification the way he wants, and I have the guarantee that he reads it. When a pull request is merged, we move the issue to the ready for release column. So again, I can see where the project stands on one side. And we do another thing here automatically. We create a dev build and we deploy the dev build to our customer's product management team. This is very cool because the customer can start testing immediately when we are finished with developing the feature, and he can start testing, he can give us some feedback, and I don't have to give him the test builds manually. We also create source maps here and upload them to our bug tracking system, so we're able to see what happens during the testing of the customer's product management team. So when there are any errors, we are aware of that and we can fix them very fast. So I said we start our automatic pull request review. So what is this and what do we do there? So basically, when a pull request is opened on our CI and CD server, a pipeline is triggered and we do some tasks. And when the pipeline is finished or there was an error, we report back to our code management system. And the first thing we do is we check for merge conflicts. That's a no-brainer. I think it's the same in every project. When there are merge conflicts, the PR gets back to the developer who opened it and he has to solve the merge conflicts. Second one, think it's a no-brainer too. We have to ensure type safety with Flow or TypeScript, depending on the project. For those of you who don't use Flow or TypeScript, you should definitely do, especially if your code base is growing. It's really helpful. Then we ensure a certain level of code quality and code formatting with ESLint and Deepcode. I'll come to Deepcode later on, but first I want to say some words about code formatting. Code formatting and enforcing code formatting is really important for the manual review process. If you have to do a manual review and you have different code formattings, it's really hard because everything looks like it has changed. And if you enforce code formatting, the same code formatting, it's very easy to do the manual review because you see the exact line, the exact lines where there were changes. And so this is really helpful for the manual review step. Now to Deepcode. Deepcode is an interesting tool. It's a Swiss company. We started using this some month ago. It gives you some interesting insights and hints and information about security problems of your code. It's based on a self-trained AI. It's used by developers in a lot of big companies already, like Google, Microsoft, Amazon. And the best thing is it's free for up to 30 users. So the integration is very easy, so it's just a few clicks. So I would definitely recommend it, so you can try it out if you want. Next thing we do is we run all our unit and snapshot tests and we ensure that our test coverage requirements are met. We do this to ensure that every developer is writing tests for new code and is adapting tests for the code he changed. Last but not least, we run builds for iOS and Android simply because we want to ensure that the builds run on our CI, even if some developer added some native libraries or anything like that. We don't want to have this, yeah, but it's running on my machine thing. It has to run on our CI. And only if all these steps are successful, a human starts reviewing the pull request. So if you look at these steps, we achieved two things. First, we save some time because we don't have to do the steps manually. Second, we ensure that some rules and requirements are enforced, which ensure a higher code quality and product quality. This is how it looks like inside our Bitrise. So we do have this drag and drop like editor on the left side. You see the steps here of one of our simple automation pipelines. We activate a SSH key. we clone the repository, we set the node version we need. So yeah, we're still on node 8. We have to upgrade here. Then we install the libraries, we run our flow, lint and jest tests. That's basically one very simple automation pipeline. And we do have the option to change this via a YAML file. This is what you see on the right side. I really do like the YAML file because you can make changes very, very fast. So this is our review process, our automatic review process. Next thing before releasing is testing. And we do like automated testing a lot because it saves us a lot of time for our React Native app. So I already talked about unit testing and snapshot tests, which we ran on every pull request. We also ran them before every release. We are using Jest and the React Native testing library, which, by the way, is maintained by our hosts, the awesome call stack team here. If you haven't used it, you should definitely give it a try. It's an awesome combination and a very cool tool for unit and snapshot testing. But when talking about testing before release for our React Native app, I want to focus a lot of end-to-end testing because these are the tests which save us a lot of time on every release. And when talking about end-to-end testing for React Native apps, first thing which comes to mind is detox. And there was an interesting talk last year by Wojciech Nowak. You should definitely have a look if you're interested in detox. And he gave some interesting insights. And we also have some detox tests in place. But since our main goal was to ensure that the app is running smoothly and looking good on all common Android devices, and I think you all know Android has quite a few different devices in place, we ended up using Appium and AWS Device Farm. A problem is Detox isn't running on AWS Device Farm till now, so we had to use Appium, which is not a special tool for React Native. It's for native app testing and web testing, but it also works for React Native apps. And AWS Device Farm is a service from Amazon where you can test your app or can run your app on real devices. So this is a pretty cool service for us, and I'm not 100% satisfied with this solution because, as most of you know, Appium comes with some downsides. For example, you have to use accessibility labels to identify your buttons and so on. But it does save us a lot of time, and it makes it possible for us to test all our core features in all different configurations on all common devices before every release. So since this really saves us a lot of time, I want to give you a short demo. So this is how it looks like inside our Bitrise, our CI/CD server. So we have this pipeline, which is called auto-test build. Again, we have the SSH key, we clone the Git repository, we install the libraries, then we fetch some content, so we have the latest content and translations and so on inside our app. Then we do the Android build here. You see the sample release command. We still use the sample release command. Then we bundle our tests, which are basically Appium Python tests. And then we deploy to AWS Device Farm. So we authenticate with our key and our secret. We choose the region. We choose the unique identifier of the project. We upload the test bundle we just created. And we say, okay, it's an Appium Python test. So it gets stored on the device farm. And then we have this run test step. Again, we authenticate, we choose the project. Then we choose the test package, which basically is the test package we just uploaded. Again, we say it's an Appium Python test. Next, we say, okay, we want to test on Android. We choose the platform. Then we choose the APK we want to upload and test, which basically is the APK we just created. And then this is a very cool thing. We choose the unique identifier of the device pool we want to use for testing. So you can have different device pools, which are just devices grouped to a device pool, which you then can choose for testing. Here we can say if we want to wait for the test results, which we want to do because if all the tests pass, we want to make a release build and deploy it to the stores. And here we get some information back from this step. So we have a detailed information available as JSON, and we do have a results summary, it's called, which we could use to send a Slack message or make a Jira comment. This is how it looks like inside the AWS device farm. This is a test I ran a month ago, but I wanted to use it here because it failed on 4 devices. And as you have seen, AWS realized, okay, it's the same error on all 4 devices. So it says, okay, it's 1 error, but it occurred on 4 devices. So let's look into it. We see, okay, it was our test suite which failed. We have this test specification log where we can have a look when the test failed. Okay, so here we were looking for this next button, and the element could not be located on the screen. So simply we wanted to press a button which wasn't there. We also get some native logs and some performance analysis, which is quite interesting. And we get this video recording of the test. So we can forward a little here and see what was happening inside there when the test failed. So here we did work with some sleeps to wait for the button to occur, but loading took too long, so the button wasn't there. We could have a look at a faster device. So here you can see the loading was much faster, and the button was there on time, and the test went on. So this was how it looks like inside Bitrise and AWS Device Farm. And next interesting question is how to handle the test results. So there are 2 easy cases. The first one is the tests pass on all devices. So easy, we start a production build and we deploy to the stores. The second case is easy as well. The tests fail on all devices. So that means we have some kind of error in our tests or in our code. So we have to have a look at this and have to make a fix and try again. Interesting thing is when the tests pass on some devices and don't do on others. So this can have a lot of reasons. So as you've seen in the screen recording, we simply didn't wait long enough for the button to appear. So I would say, okay, we have written a bad test, so we have to adapt our test. But it could also be that a device isn't available or a device has no internet connection whatsoever. So you have some kind of flakiness when using this end-to-end tests. And we haven't found a great solution for that. We tried to work with some percentage values here to say, okay, if 90% of the tests pass, we go on and start our production build. But at the moment, we fell back to, we just create a new issue inside our Jira board, which basically says, okay, the tests didn't work on all devices as expected. Please investigate, have a look, and decide how to go on. So this is how we are handling this at the moment. There can be other ways. So again, it's not the one way, but it's just an idea how to handle this. But again, it really, really saves us a lot of time, this automated end-to-end testing. So next step after testing is making the release. And I think I can keep this very short because it's just automating a list of steps you had to do manually. So we clone the repository again, we set the node version, we install the libraries, we fetch our content, we set some version numbers, we install the native libraries, then we make the bundle, we deploy it to iTunes Connect. We then install our Bugsnag SDK and we build and upload our source maps to our bug tracking system. We do have a similar pipeline for Android, so we can run them in parallel, so we're able to make releases very fast. Just a little side note, we do not automatically create release notes and screenshots. We could do, but we decided not to do because we think the developer shouldn't be responsible for writing the release notes. So this is part of our customers' content management team or product management team. And these release notes, for example, are written by hand in our projects. Now our application is in the store and gets downloaded by our users. That's where the last step of my talk today comes into play. Bug tracking and stability monitoring, and where automation can help you there. So first of all, you have to collect your errors in your production app. This can help you find and fix errors so much faster. I think most of you do, but for those who don't, you should start collecting your errors in your production app. It's really easy. All the big tools integrate into React Native very easy. It's just some commands and some lines of code you have to change. So it comes with no effort. So you should start doing this. So when you collect these errors, that's the one thing. But be honest, who of you is aware what's really going on in the bug tracking system? So at least we had the problem at some time that we knew we have some errors in our bug tracking system, but we little bit lost control what really was happening there. So how many errors do we have there? How important are they? So we looked in there from time to time, but we didn't give it the importance it had. Yeah, we should have. So this changed massively for us after we automated this to add all unhandled errors to our single point of information. So now every new error which occurred in our bug tracking system was sent to our Jira. We had a new issue there and we defined responsibilities for this issue. So we assigned it to one developer and he has the responsibility to categorize it, to prioritize it. So we know exactly what we had to do. For that, it's really important or a cool thing to add a link to the details to the bug tracking system. That's just a little hint because the developer who makes the prioritization should not have to go to the bug tracking system and search for the error and so on. He just should have to click a link and get all the information. What would be even better would be to include the needed information inside the issue. And again, use source maps for React Native. They are really, really helpful. So I want to give you a short insight in our Jira, how it looks like. We do have the line of code. Since we use source maps, we do have the link to the details, and we do have the error message. But I'm not quite satisfied at the moment, so we have to change some things here. So, for example, we're missing the devices where the error occurred. We are missing the number of occurrences. So we don't really have enough information to make a decision in this issue. So we have to look inside our bug tracking system. And this really helped us save a lot of time because we simply don't have that much bugs now since we fixed a lot. And when a user comes with a bug description, we normally know exactly where we have to look, and most of the time we already have fixed it. So let's get back to the illustration from the beginning. So in 2020, we sat down again and looked at what we were doing now after we made all these changes. And the cool thing was we more than doubled the time we had available for feature development. So we were still able to run the same release cycle of 3 weeks. And we were still able to develop a lot of features because, and that's the best thing, we didn't have to do these repetitive tasks no one really wants to do anymore. So yeah, we won on both sides. So let's sum this up in 4 key takeaways. First one, automate everything you can. For every step in the process, on every task, we do think if we could automate it. There can be done a lot more automation, and we're on it. So if you have some ideas, you can contact me. I'm always looking for more automation. Next thing is automation brings you not only a faster time to market and a shorter release cycle, but it also brings you a higher product quality since all the requirements you can set and so on. Third one, there are really great tools out there to use with React Native. So don't try to build some tools for your own. Look at what's on the market and use the tools. They're evolving rapidly, so it's really helpful to use the existing tools. Last one, collect all your information in a single place, which we call single point of information. It's really helpful to be able to go there and know exactly where your project stands, what's going on in your project, who is working on which issues. So I would really recommend to have and collect all the information in this single point of information. So to end my talk, I want to sum this up, the whole talk in one sentence, and it is: only use a human where a complex decision or any kind of creativity is needed. Automate the rest. That's it. Thanks for listening. If you want, you can reach out to me via email or via my LinkedIn account. I'm happy for any kind of discussion and feedback. Thanks again for listening and have a nice conference. Bye.
Thank you, Alexander, for that. Again, these numbers are unbelievable. I just can't wait to use all of these in my applications, and I'm pretty sure that everybody will benefit from these learnings. So let's move on to our next speaker, Talia, and she is going to talk about feature flags. She works at Split Software. This is a company that actually makes a solution for feature flags. Now, if you don't know what feature flags are, don't worry, we'll learn about them in a second. I can tell you that these are a small features or libraries or solutions that actually allow you to swap some functionalities depending on the settings that you want, so that you can maybe do A/B testing or all sorts of different scenarios. So I'm not here to tell you what the next talk is going to be about. That's the job for Talia. She will tell you everything you need to know about it. So let's welcome her onto our React Native EU stage and learn about feature flags with React Native.
Hi everyone. Today we're going to talk about controlled rollout with React Native and feature flags. So I'm Talia. I'm a developer advocate at Split, and this is my contact information. I'm on Twitter. You can email me. And I want to start off, I want to introduce you all to my friend, Debbie the web developer. And Debbie is a web developer who has spent most of her career doing JavaScript development, mostly with React, but all mostly front end as well. And Debbie recently just joined a mobile team that uses React Native. So she gets assigned her first feature, and she writes the React Native code, and she gets it reviewed, and she tests it, and she pushes it to production, and the new version gets uploaded to the App Store. But then something really bad happens. There's a problem with the code, and Debbie breaks the entire app. Oh no, what are we going to do? So in order to fix this, Debbie has to release a fix to the App Store, but she has to wait 2 weeks to do it because of App Store regulations. And now Debbie is so worried that she's going to lose her job. So this is Debbie's friend John, and John is also a web developer on the team, and he also does mobile development. And he suggests that they use code push and that they use that to push out a new version without waiting for the App Store. And code push is a tool that you can use to dynamically update the experience to your React Native app. So phew, crisis averted. We're going to use code push. It's going to be great. So a few weeks later, Debbie is working on another feature that allows users to scan a barcode with their mobile device, and then the barcode will find that specific item for them and tell them information about that item, product details and pricing and things like that. But lo and behold, Debbie releases this feature and it breaks the app again. Debbie, what are we going to do with you? But Debbie is not worried because she thinks she can just use code push again. So Debbie and John do some digging and they realize that they can't use code push because the bug is in the React Native code that's accessing the camera. Now she really thinks she's going to get fired. So Debbie and John are talking about what they're going to do and how they're going to resolve this. They can't wait 2 weeks to fix the bug. They can't wait 2 weeks to release a fix to the App Store. So what are they going to do? They figure out this like really hacky solution in JavaScript where they temporarily disable the new feature while they're waiting for the new version to get released. And then all of a sudden, a mysterious stranger appears and points out to Debbie and John that that thing that you just did is called a feature flag. When you temporarily disabled that feature, you're basically using a feature flag. And Debbie is so confused. She's like, what's a feature flag, Yoda? And Yoda explains that a feature flag lets you separate code deployment from feature release. And Yoda explains that feature flags provide this sort of safety net for your features. So what this means is that you can turn on and off features without a lengthy release process. So Debbie or Debbie's product owner or anyone on Debbie's team can turn on features or kill features with just the click of a button. So that means no one has to push up new code or revert code, or you don't have to do anything code related to have this fix in or to have any new feature in. So you don't need a release process to make changes to your features. And with feature flags, you can target your internal teammates, test your code in production, and then release it. So Debbie can add herself and John and her other team members inside of the feature flag, keep the default off for the rest of the world, and test her code in production without affecting end users. Then there's all these other safety nets with controlled rollouts. And Yoda explains that with controlled rollouts, you can release new features gradually, ensuring a really good user experience for a small group of users before you release them to your entire user base. So this means that Debbie's team can control the rollout for her barcode feature, and she can roll out the barcode feature to 5% of their users to make sure it works. And if there's any other bugs, that they can roll the feature back. And another thing they can do is they can A/B test to see whether or not users who have the feature spend more money on the app, or how it affects iOS users versus Android users, like what's the performance difference. So with feature flags, you're getting this extra layer of risk mitigation in case something goes wrong. And Yoda advises them to use controlled rollouts next time they roll out a new feature. And that's exactly what Debbie and John do. So in the future, whenever they released a feature, they used controlled rollouts to mitigate the risk in case there was a bug. And they took Yoda's advice and they started using feature flags to do controlled rollouts. So all they did is go into the feature flag configuration page, and this is what it looks like in Split, and they set what's called targeting rules. And targeting rules really just define who sees a feature and who does not. And here, Debbie and John are saying that they want 5% of their users to see this new barcode feature, and the remaining 95% are going to see the existing or default behavior. And then as Debbie and John's confidence increases in the barcode feature and they know that it's working for more and more users, they can slowly move this to have 100% allocation to their user base. So now Debbie and John are as happy as can be because they have this new process for mobile controlled rollout with an extra layer of risk mitigation through feature flags, and it works really well for them, and their confidence is high and their developer velocity increases because of this new process with feature flags. But there's always these naysayers and these negative Nancys, and in our case, this grumpy old dev, this grumpy old developer. So this grumpy old dev comes in and he starts being really negative, and he goes up to Debbie and John and he says, hey, your plan only works when you have a strong network connection because you need to pull the current feature flag status from the server. But when you're doing this with mobile development, what happens when you don't have a strong network and you can't load the feature flag configuration? What do you do then? And Debbie and John are like, you know what, grumpy old developer, you don't scare us. We use caching. Debbie and John use Split for feature flag development, and with Split's updated caching feature, they can cache their feature flag data so that all of their mobile users now have access to the personalized experience wherever they are, regardless of their data connection. So Debbie draws out this diagram and talks Grumpy Dev through it. So basically, they need a way to get the feature flag configuration from the feature flag system, which is Split, to the phone. And what do you do if there's no connection and you can't connect to the feature flagging system? You look at the cache. So by automatically caching feature flags and pulling updates for those flags every 15 minutes, your newest changes will be reflected to your users regardless of their connectivity at the time that they run your application. And so what's great about this is that the data refreshes every 15 minutes automatically, and there's no human intervention needed, and there's no extra code that's needed. And this is really great for connectivity issues. So Android and iOS caching and mobile caching, this allows flags that control exposure to your new features, improvements, and bug fixes to be regularly updated and stored in the cache for instances when connectivity might not be available. And so by caching your app data locally on each device, you allow your end user to have access to all of the functionality, even when they don't have internet access. And this is really important for mobile development, especially with React Native. And it's really great for users who travel internationally or who always don't have great network connection or who are frequently outside of their data service area. It also speeds up the load time in areas where connectivity is limited because the app can load from the cache while awaiting updates from a slower moving data connection. And then grumpy old dev says, okay, fine, you got me there, but Apple will reject your app because if you keep making changes more than 2 weeks, more frequently than 2 weeks, it's against App Store regulations, so you're not going to be able to do this. And Debbie and John just smirk, and they're like, hey, Uber has thousands of feature flags in their iOS code base, and if Uber can do it, so can we. But in all seriousness, a lot of apps use this technique, and Uber even published an academic paper on this. And if it's good enough for Uber, it's good enough for us. So Debbie and John have defeated grumpy old dev, and they continue to use controlled mobile rollouts with feature flags. And again, this process has increased the entire team's developer velocity, and they spend more time creating new features and less time with bugs and defects because they find these bugs and defects earlier in the process, which also saves the team money because the earlier you find problems, the cheaper it is to fix. So let's talk about React Native and how this is done in the code. So you might be wondering how Debbie uses feature flags for real in React Native. What does she do? How did Debbie do this, and how was it implemented? So in Debbie's React component, she adds the split treatments component, which is given to you in split in our SDK, and it returns the proper treatments based on the name's prop value that we pass to it. So the name of the feature flag here is enable barcode shopping, and all she does is wrap the feature with the split treatments component, and then the code inside of that will then know whether the feature, the show barcode experience, is on or off for the current user. So based on the targeting rules and the treatment rules that you put inside of your configuration in the UI, Split will know if the treatment is on or off for the current user. And if the flag is on for the user, they're able to see the barcode. And if the flag is off, they won't get the barcode experience. So this is how you can control your user's experience without pushing up new code. So as long as Debbie has this split treatments in her render component, then in the split UI, she can say, I want only our internal users to be able to initially see this feature, and then I'm going to test it in production, and then I'm going to roll it out to everyone. Or she can say, I only want people who are in this region or with this device type to be able to see the feature, and then anyone else who's not in that region or has that device type is not going to be able to see or experience this new barcode feature. So basically everything can be configured in the split UI, and what's great about it is, again, you don't have to touch any source code to make these changes, and you don't have to touch any, you don't have to use GitHub to push up any new code. Everything is done in the split UI. So I just want to thank everyone for listening. If you have any questions or comments, I would love to get feedback from you on controlled rollouts or feature flags. Like, what are the use cases that you use? You can tweet me and or email me. I'm happy to answer any questions or talk about this in more detail. But thank you again, and I hope that you all have a great day.
Thank you, Talia, for that. Really great. I think feature flags are really powerful, and I'm great to see that some of these are easy to do with React Native. I'm hoping that it will make that more popular within the community. Now, let's move on to our last but one speaker, Sébastien, and he is going to talk a bit today about React Native and Jamstack and Gatsby and MDX and generating files from Markdown and writing text files and all sorts of different crazy things. And if you feel like these have nothing in common, don't let it fool you. There is actually a lot of important and exciting stuff inside it. And Sébastien has been using these tools to generate some cross-platform content automation and generally generate content cross-platform. And since I've been using Gatsby as well to generate cross-platform content for my website and some pieces of React Native, I'm really excited to learn how he's been using that and what kind of challenges Gatsby allowed him to solve. So let's welcome Sébastien onto our virtual stage and learn about React Native and Jamstack from the presentation that he has prepared for us today.
Hello everyone, I'm Sébastien Lorber and I'm going to talk to you about ReactNative, Jamstack and maybe a bit more. I'm a freelance and I'm currently working with Facebook on Docusaurus, which is a Jamstack documentation framework that you probably heard of because it powers the ReactNative website, React Navigation, and Jest, and many other projects from Facebook, and many people use it. So this talk is not about Docusaurus, but this is an interesting project. This talk is about the story of my blog and the various cross-platform experiments I've been running on it over the years. 3 years ago, I wanted to have a blog to be able to write a technical blog post because I'm a software engineering for many years and I still didn't have a blog. I wanted to be able to put interactive content in this blog, so demos and things people will be able to play with. I wanted it to be a sandbox so that I can learn new things, like new libraries, new tooling, and I wanted to build fun things. And maybe it will be overkill, but it's not a problem. So I've heard of this thing called ReactNative Web maybe 3 or 4 years ago. It's something that really interested me because it permitted to build a web application with ReactNative. I thought this was very interesting, and we have seen over the year that big players like Twitter and Uber have adopted it. So this is really something I wanted to learn, and I tried to apply this to my blog. So ReactNative Web has a concept called Atomic CSS in JS. Maybe you've heard of it. If you don't know what this is about, I've written a blog post about it. But it's CSS in JS where each CSS rule has a different class, which permits to have nice scalability properties of the CSS. The new Facebook.com is using also Atomic CSS in JS, but it's not based on ReactNative Web. So I had a very ambitious blog project initially because I wanted to use like every technology I've heard of but I've never used before. This was three years ago, and you know what happened when you do that. 2 years later, I didn't have a blog, so I've decided to pick a Gatsby theme novella, which is a nicely designed Gatsby theme, and which permitted me to get started very fast and write my first blog post finally last year. So these 2 years I've lost trying new technologies were not totally lost because I was able to create the Gatsby plugin for ReactNative Web during this time. And the thing is, I've been able to integrate it with my existing Gatsby blog that I started last year, as it plays nicely with any Gatsby site, so it worked well with Novella too. So let's start to see how we can run ReactNative inside Gatsby. So how can we run ReactNative inside Gatsby? First, what is Gatsby? Gatsby is a static site generator. It's based on React, and it builds a single-page application. So the React framework run on the front end, and you have all the power of React inside your Gatsby site. The only difference is that some HTML pages are created at build time instead of being created lazily on the client. So everything you can do in things like React app, you can do it in Gatsby too. It's just that you have to handle the server-side rendering. Gatsby also has first-class MDX support. We will see later what is MDX and how it's related to my talk. But first, let's see some details about ReactNative Web. So ReactNative Web is somehow a library that permits to convert ReactNative code to React DOM code so that it can run on the web. It is separated into multiple parts. There is a Babel plugin that permits to rewrite the import from React Native to import from React Native Web. And then there is the runtime of React Native Web, which re-implements the React Native primitives with DOM components. So somehow there's nothing magic, it's very simple conceptually. When React Native Web re-implements these primitives, it takes also in consideration the specificities of the React Native platform, like every elements are using Flex, so you cannot opt out of the display Flex when you are using React Native for the web. And by default, the Flex direction is colon instead of row. So here it's a very, it's a fake implementation just to help you understand how it works. So how do we integrate Gatsby, React Native Web on Gatsby? We have to handle the server-side rendering. So somehow we can think of React Native Web like a regular CSS in JS library, like emotion and style components and things like that. So when you integrate it with server-side rendering, what you have to do is to render your application on a static route. You get the HTML back, and normally the CSS in JS library you use permits you to extract the critical CSS that was used on the page to be able to get the CSS as a string, and then we put this critical CSS in the page as well as the HTML, and then we write it to the file system to have an HTML file. So let's see an example of a Gatsby page. So this is a basic Gatsby page. So for example, you have a pages folder in Gatsby, and you can create such a page. And here we can see that the page is using the React Native primitive elements like view and text and touchable opacity. And this gives us this result. So this is the first page I was able to get running using React Native inside Gatsby. And it also works, this is a demo that I run in dev mode, but it also works with server-side rendering. So if you run a command like Gatsby build to get the static website, you will get this page. I mean, the content will be in the page. It will not just be working on the client, it will also be in the first render of the page. So there are some details I'd like to share with you. Here, for example, you can see there is a button component. It is using touchable opacity and text. So both elements from React Native are compatible with the web thanks to React Native Web. So this component is able to run on React Native, but it is also possible to run in at the web thanks to React Native Web. So let's take another example. This component is a Gatsby page. It is different because it mixes up React DOM elements like div and h1 and the link of Gatsby, which is a React DOM element, with React Native elements. So we have a way to convert React Native elements to React DOM elements thanks to React Native Web, but the opposite is we don't have a way to convert the div to React Native elements. So this component will only work on the web, but it won't work on mobile if I want to. So now let's see what is MDX exactly. So MDX is somehow markdown on which you can put React components. So this is nice because it permits to create interactive blog posts. I can start to add a markdown title and some markdown paragraph, and then I import a component, and I'm able to insert this component inside the markdown. The nice thing is that your interactive content run without any iframe or constant box or things like that. You don't have to import a lazy loaded iframe to have the demos working. It's embedded directly on your site, like if it was coded manually. So let's take an example here to see how it can work with Gatsby. We can see there is at the top there is a blog post where there is a React Native button that we import, and at the bottom, we see that we import the MDX file, and actually this import gives us a MDX component. So it's a real React component that was compiled from by MDX from the MDX format to JSX. So we can use it like any regular component. And if you want to see what this gives us, here is the blog post running by Gatsby. So the first version of my plugin, I've got the proof of concept working. The output is a real Jamstack site. So this is a static website. The Google crawlers are able to index it like any Jamstack website. It's performant and secure, and it's very easy to deploy for free anywhere. So like Netlify, Oversell, if you like its providers. But this first version has some limits. For example, there was no WebJS extension. So for example, if you do React Native, sometimes you want to create a platform-specific code. The problem with my first version is that I didn't support that. Although there is something very important for React Native, is that the libraries are published to NPM, not transpiled. So it's not code that can run on the web by default. So you have to set up the transpilation of some of the libraries you plan to use. There's also no dev annotation on my first version, and also no support for Expo image modules, because maybe you know that Expo has tried to make these libraries compatible with the web. So to make this sustainable, we need a bit more Webpack configuration to have something usable. So here is a version of the second version of the library that I've built. So I've made it compatible with some UI kits like ReactNative paper and things like that, so that it's possible to actually use a ReactNative library on a Gatsby site. So this is a Gatsby page that is also a Jamstack page, and you can see that the ReactNative interactive components on this page are working nicely. This is another example which is a bit the same. So instead of using UI kits, I just try to build some small to-do app with ReactNative paper. So there is a to-do list. Behind the scene, there is a GraphQL server and TypeScript also. So I think it's an interesting stack, but let's keep this for now. So the version 2 of the plugin had some limits too, because I only added the lib transpilation to be able to make it work with libraries like ReactNative paper and things like that. The problem is that the library for which I set the transpilation was hard-coded, so every time every new library needs to be added to the plugin to solve this, or the user has to provide explicitly the library he wants to transpile. So this is a bit annoying to set up, because we have to think, should I transpile this library or not? So this is a bit annoying to maintain. Plus, sometimes there are also things in the libraries that do not work, like for example ReactNative SVG, which may require additional setup to work fine. So let's see what Expo has done for the cross-platform ecosystem. First, Expo somehow can be seen as an extension of ReactNative core because it provides us many more APIs, like the camera, the video, the fonts, the image picker, the image manipulation library, and things like that. I really like Expo, and I think it's very great developer experience to work on React Native and also on React Native Web with Expo. Whenever they can, they try to craft API surface that is compatible with the web and provide web implementations for their uni modules. So Expo has published a Webpack config, and this is the config from Expo that I'm using in the Gatsby plugin version 3. So the setup is much more simpler, because we just have to get the Gatsby Webpack config and wrap it with the helper of Expo, and then the things are working. So all the complex configuration is done by Expo, so that it adds the basic React Native web support, like the Babel plugin. It adds maintained list of libraries to transpile based on regex and things like that. So, for example, all libraries prefixed by React Native will be automatically transpiled. There are other things that they add, but I don't even know exactly all the details. But it works, and this config permits to make Expo and React Native work on anywhere there is Webpack. So you can do this with Gatsby, you can do this with Next.js, React App, Electron, or even a custom Webpack setting. So thank you, Evan Bacon, for all the work you have done, because this is great, and this makes this much more easy to use for anyone. So let's take an example to see if we can use a video component from Expo directly in a blog post. And so here it's a MDX blog post where we import the Expo AV video component, and we play the video. We can see that it works. The video plays directly on the blog post. I've built other demos that are available to see on my blog. If you want to check my blog and try the demos, they are all interactive. So, for example, here is a React Native SVG component. I think it's nice because you have a SVG that you design for React Native, and then you can use it on the web too, if you want to. Here's another demo with the Expo camera. So this component is the camera from Expo, where you can see your face or use the backward or front camera. Here's another demo with the gestures. So if you want to play with the React Native gesture handler, it works on the web too. Here is a demo with Expo image picker and Expo image manipulator, which permits to pick an image and then apply transformations to it, and it works on the web too. This one is another demo that I think is pretty cool, because Expo dark mode switch is a third-party library. It's not really part of the Expo SDK, so you have to. It's a JS-based only solution that is built on top of just React Native Web. So it has not any complex dependencies, but this is a third-party library which use animations with the animated from React Native directly. And we can see that it's not very hard to publish a standalone library that is actually compatible with cross-platform. So hopefully, maybe in the future, we will have much more libraries like this that are cross-platform and that we can use both on mobile and on the web. So the takeaway of this part is that the support for web is good in React Native and Expo. It's possible to use all this on the Jamstack too, whether it's Gatsby or Next, and it's SEO friendly, so Google will be able to index your site. It's not so risky because there is always the platform extension fallback that you can use. So if React Native Web isn't able to convert properly your app, you can still use, if you want, you can use React Native Web and put some jQuery in the file and it will work. So I think this really reduces the risk of using React Native on the web. So I don't know if there are many use cases for this, but maybe you have a cross-platform design system in React Native, and if you want to reuse it on your marketing website, maybe it can be interesting to give it a try. So now let's see if we can do the opposite. So what I mean by opposite is running MDX in React Native. So let's consider a simple blog post as a source. So this is a regular MDX blog post with an embedded component. Let's see how MDX compile it. So the MDX does its job and it compiles the markdown file as a React component. So the thing is, we can see that there are DOM elements in this component, so we'll see later how to handle this. The second part, it's a part that is by default. So if you don't change the default ReactNative settings, it's already there for you from the ReactNative Babel preset, and it transpiles the JSX to JS so that the JS engine is able to use this. Here, take attention to, you can see there are React.createElement calls. We'll see later why this is interesting. So we have a problem here. We have run the MDX transpilation on the blog post. The problem is that MDX gives us React DOM elements. We have div, we have h1, we have paragraph, but these elements don't work on ReactNative. So how can we make all this work together? Somehow we need the opposite of ReactNative Web. ReactNative Web permits to convert ReactNative to ReactNative Web. Now we need some way to convert React DOM to ReactNative. So the solution I found was to use the JSX Pragma and the MDX provider. We'll see how it works. Another possible solution that came out later was Expo HTML elements, but I didn't try to get it running. So let's see the solution I found to solve this problem. So the JSX Pragma is a command that you put at the top of your component, and if you do that, the Babel transpilation replaces the React create element calls by the pragma that you declared at the top of your file. And if you take the source code of the blog post and then you apply it the pragma we want and you transpile it, in the end the JS engine receives this code. So we can see that it doesn't contain anymore React create element. It contains the JSX function calls that are imported from the MDX import. So this part is important because it has to be done for the MDX provider to work. And then the MDX provider kicks in. This component permits somehow to override the elements that were generated by MDX. So, for example, we create the opposite mapping of what ReactNative Web does. So we convert a div to a view, we convert a paragraph to a text, and we convert an anchor to a text on which you can press and open a link. So you have to provide a mapping for each DOM component to make this work. So let's see how these two work together. At the top is the blog post once it's converted. At the bottom is how we use this blog post in the application. So we import it. We import the MDX component that was generated from the MDX source code, and then we use this component, but we wrap it in the ReactNative MDX provider so that the DOM elements are converted to ReactNative. And this gives us this blog post running on a mobile app. So this is an iOS simulator. It's not web this time. It's really a mobile, native mobile blog post, ReactNative blog post. So now here is a real blog post. Does it work also with a real blog post? I've tried to do this with my own blog post to see if it was possible to make them run. So here are two errors I got a lot. The first is that there are missing DOM conversions. So for example, I forgot to convert the UL element to ReactNative, so this gives us an error. And there are also errors that are related to not wrapping ReactNative text by the text element from ReactNative, because as you know, ReactNative is a bit more strict regarding text element. Every element has to be wrapped in a text tag. So you have to maintain a big mapping from React DOM to ReactNative, but once it's done, globally it works fine. There's another error that is related to images, because the way images work on the web is not the same way it works on ReactNative. So for example, if you have, you can't use a relative path, you have to use require calls. So I found a quick fix was to just replace the relative path by require calls, so that React Native is happy and is able to consume the image. So in the end, we get this blog post. It's running on the mobile application, but we can see it's a blog post, but it's not very friendly. There is no header, there is no title. So we can add generally in the blog post there is front matter, which is metadata at the top of the blog post that permits to add metadata like the path of the main image, the title, and maybe the publication date and things like that. So here for now we are according the front matter just to test that the proof of concept is working, and we get a blog post like this where it's possible to scroll and we can see that it looks better. So this is nice, but building a mobile application with just a single blog post is not very interesting. So maybe we can try to see if we can generate automatically a mobile application from all the blog posts. Can we add navigation to this, and can it be integrated in an existing mobile application? So let's see how we can build this. The first step is to automate the compilation of MDX to JSX. So here it's a node script that I run at build time. The idea is that we read the content folder, which is the folder in which I put all my blog posts. And for each file, we compile each file to a JSX file. So how does this compilation work? The first step is that we generate the pragma. The second step is that we extract the front matter and we expose it as an export. And the third step is that we compile MDX to JSX, and then we concatenate all that, and we have the final source code of the component. The second step here is to generate the list of blog posts. So we want to write a source code with a list so that we can import this list and use it somewhere in the app. So here is the sub-tree is the navigation of the application. So we are creating a stack navigator with a root screen that is the blog post list, so that we can browse all the blog posts at once. And there is another stack screen that permits to browse a single blog post. And then we create the application, so we use the navigator and the MDX provider globally, so that all the MDX components are converted. Here is the example, the blog post list. So we import the blog post list that we generated, and then we render a card for each blog post in a scroll view, so there's nothing fancy here. Here is the blog post screen, which permits to render a single blog post. So a blog post contains the MDX component and the front matter. We create a custom component to render the front matter header of the post, and then we add the regular MDX content. And we can add a back button to be able to navigate back to. So in the end, we get a real mobile application that works, on which we can navigate from one blog post to another. But what I think is very interesting is that the interactive content is also working on the mobile application. So I think this is great because the demos that have been built using Expo and React Native are able to run both on the web and on mobile and natively. So the takeaway is that MDX is cross-platform, React Native is cross-platform, Expo is cross-platform, so it's possible to build interactive content based on MDX that is cross-platform. And this is what I've built. So now, let's see if we can automate all this. Because for now, what I do is run the scripts locally, but maybe it will be interesting to automate a bit with continuous integration. So for example, here are two scripts that I created. The first one is to be able to build Gatsby. So I run this on Netlify to deploy the site like any Jamstack site on Netlify. And the second script is the script to publish to Expo. So first we need to compile the MDX with the node script that I showed just before. And then we need to run the Expo publish command that uploads the Expo app to their CDN. And then we get a QR code to be able to use the mobile application. So maybe you can scan this QR code later. I will show it again on the last at the end of the talk. So the CI automation gives us free platform. We are able to publish on iOS, Android, and web. It's nice, but there is something more that we can do. The React Navigation 5 has web support, and Expo also has a command to export your mobile application as a mobile web app. So why not trying to use it and see if it works? And it does actually. I've created another Expo build web command in my pipeline, and I'm able to deploy a mobile website based on React Navigation to Netlify. So if you want to see how it works, it's the same site as my Gatsby site, but this time it's not using Gatsby, it's using React Navigation. So this is not so SEO friendly than the Gatsby one, but I think it's a cool demo. So the takeaway that we here now, I just need to commit a new blog post to my repo, and then everything is deployed. But sometimes there is a bug, like sometimes my conversion logic is not perfect and it doesn't work. And I think it's nice to be able to get a mobile website this way, because I didn't have to do anything. It came for free. But the problem is that now I deploy too much things on Netlify and I have to pay. So this is not good. So here there is a last question that we need to answer is, what about the other platforms? So by other platform, I mean, we have seen that we can deploy on iOS, Android, and web, but there are new platforms that Microsoft is working on, like ReactNative macOS or Windows, and there is also the TV and maybe others like the fridge sooner or later, I don't know. So the thing is, what about these platforms? Does it work to run a blog post on such platforms? And I didn't have time to try all of these platforms, but I got something working, and here is the result. You can see that it's a macOS Tray app that is able to run a blog post. So I think it's cool. It's totally useless, but I think it's cool, and I was very happy to get this running in less than an hour, and quite surprised that ReactNative macOS was already this stable and usable, and I didn't have any big trouble to get this running. So for Windows, I tried to use it, but unfortunately I had to borrow the computer of my girlfriend, so she was not very happy with this idea. So for now, I didn't get anything running. For TV, never. I didn't have time to try the other platforms. So the takeaway are that the MDX can be run everywhere. So as we have seen, even if it outputs DOM elements, you have the opportunity to override these elements with the MDX provider. So even if there is a platform, a new platform coming later, you can still provide the primitives by using the MDX provider. So I think MDX here is really a cross-platform technology that you can use everywhere. What is cool is that all this is native. There is no web view anywhere. There is no Electron or whatever. I think the ReactNative macOS and Windows platforms are ready to try. At least the first impression that I have got is that it's really quite stable already. So I think it's nice, and really hope to have these platforms production ready soon. So this is all I got. Thank you for listening to me, and I'm going to post all the links of this talk on this URL or my website or Twitter. So if you follow me on Twitter, you can get the link of all the material of my talk. I really hope that you try cross-platform. I think it's not as risky as you might think it is, and maybe get started by running cross-platform experiments on your own blog, like I did in mine. If you want to try the talk material, this will be available on the link, so you can try the website with the blog post with Expo demos in it. There is also the Expo application and also the mobile website. Thank you.
Okay, thank you, Sébastien. Really great talk. I still have to wrap my head around it because it's really exciting and advanced, but I can see a lot of great automation behind it, so always propping things like that. So let's move on to our last speaker of the React Native EU Virtual Conference, Ramón, and he's from Vienna. And unlike most of the time when he is running and preparing Women Tech Makers Conference in Vienna, today he is going to be part of a conference from a slightly different perspective, which is speaking, not organizing it. So I think that Barbara now has no choice. She has to apply for the next edition of a talk. And I can see her shaking yes, so I guess we will wait for her talk to be sent over. But Ramón is going to talk today about something very important, something that we all have to do at least once in a lifetime, which is upgrading React Native application. And this has been a challenge before, now it's becoming easier and easier, but still can have some painful challenges and issues that we just all have to go through. So Ramón is going to talk about upgrading, some lessons learned, things to look at, what to pay attention to, and what are the things, steps and tips on just how to make your upgrading life easier. So let's welcome Ramón on our virtual stage and let's go through the upgrading process all together.
Hello there. Thanks for tuning in. I really appreciate you listening to my little journey. This is such a fun conference and I'm really happy to be here. My name is Ramón. Don't worry about rolling the R. Ramón is just fine. If you want to talk to me on Twitter, I'm Hola Soy Milk, as you can see on this slide. It's a pretty bad joke, and I apologize. It's Spanish for hello, I am milk. Yeah, I'm living in Vienna, in Austria, and I've been a freelance software developer for my entire career. I really consider myself a community member. I've been helping run some local and online tech communities for quite a few years now, and it's been an incredible ride. I think by learning from each other, by talking to each other, by listening, by sharing, we really help make things better for ourselves. I've also been a Mozilla Tech speaker for almost 2 years now, and that has been equally what an incredible journey for me to learn even more and improve as a person. So let's jump right into it. One of the things that I really love about freelancing is that it allows me to jump between different industries on an almost daily basis. I've been really fortunate during the course of my career to work with refugees, with restaurateurs, with doctors, and, well, right around March, when things started locking up here in Vienna, some of my contracts went into a bit of a lull, understandably, and, when I was looking around, just checking out what's going on around the communities, I saw a message posted in the Vienna freelancers Slack group where somebody said, hey, I've got a client working for a React Native, looking for a React Native developer, remote, freelance, and good rate. That's 3 things that I'm very happy with. So I reached out to them and I said, hey, this sounds like my kind of thing. I've been doing React Native for a few years now. How can I help? What's the situation? So he gave me a small tour of the code base. It was written in React Native, naturally, and also in TypeScript. Pretty new to me, but I'm willing to take on a new challenge. And by being upfront with them, they were pretty happy with that. So the client tells me, okay, so we've got this app. We've had it running for quite a few years now, but it hasn't been updated in a while. And there's two things we would like to get going as soon as possible. One is 64-bit binary for Android. So they hadn't yet updated the app to be compatible with 64 bits. And Google is pretty strict nowadays about requiring that. And on the Apple side, getting things working with iOS 13 also meant that we would need to patch up a few things to make sure that it's helping with the numerous things that Apple has changed over the years. So I thought, okay, that sounds good. What's the code base look like? How fresh is it? And so I joined the project in March, right? The last update to the app, and by extension, the last commit, were made in just about a year before that. Okay. The React Native version that was being used at the time, now I don't know if that was the newest one, I don't think so, but it was pointing to React Native version 55. Fair enough. At the time that I was already well into my upgrade, the current React Native version was 62. It was about 8 versions behind, 8 minor versions behind. So I thought, okay, first thing I'll do, as I do with any kind of code base, is to see if it runs on my machine. So I fired it up, I cloned the code base, I ran the iOS build, and immediately I was met with the problem, could not find iPhone 6 simulator. Well, fair enough. Xcode tends to throw out old iPhones and stuff pretty quickly with each major upgrade. So I thought, okay, let's see how it works on Android. Android tends to be a little more backwards compatibility friendly, not throwing any stones anywhere. So I fired it up, and similarly, the app build immediately failed, telling me that something about Google Play services was not working. So I couldn't get the app running right from a clone. So I thought, this is gonna be a little harder than I thought. I remember saying to myself, I'm gonna have to upgrade the heck out of this. So, to clarify right off the bat, you're probably wondering, what is the best practice for managing dependency upgrades? Now, there are lots of schools of thought on this. There are lots of opinions. There's lots of books. There's a lot of talks. There's a lot of blog posts with opinions on what the best practice is. This talk will not be that. If you were to ask me instead what my favorite practice for managing dependency upgrades is, I might be able to give you something a little more concrete. I like to adhere to the school of thought that dedicating specific chunks of changes or a sprint to upgrading a few things, make sure that we're on the latest security versions, is vital. Martin Fowler, a seasoned software developer who's written some books that I really appreciate, said, if it hurts, do it more often. I really liked this. It kind of emphasizes that, it's not fun, but it helps in the long term. There was another quote from a different time that I really thought resonated with how software development works for me. And that is, art is never finished, only abandoned. So, just to clarify, I'm not trying to compare myself with Leonardo da Vinci. My goodness, no. And I'm not saying that any kind of software I make is art. Okay, I'm not going to beat myself too much here. But I think a lot of this can apply with software development as well. Software projects only really finish once they're no longer being developed. In a sense, abandoned. Another question that I started wondering as I started writing this is, I don't know about you, but I get the feeling that a lot of people tend to think, a dependency upgrade, that's quite an ordeal. And I wondered why. Why is it so daunting? And I think the question of balance is what comes into play here. I think that especially with React Native, React and JavaScript projects, which have lots of small modular dependencies. In a sense, it's not just you and your team working on a software project. It's you, your team, and also hundreds, maybe thousands of contributors writing software in third-party dependencies. And managing these is kind of like a game of Jenga. You have to make sure that things are balanced and they don't topple over. And it becomes even more difficult when these dependencies have dependencies on one another. Say, for example, if I want to run the latest React Native, it would really be sensible for me to also upgrade React. So I tried to condense this experience into 5 lessons. The first of which might seem a little obvious or even cheesy, but bear with me. You're not alone. The great thing about this open source, one of the great things about working with open source software is that we can all share these experiences. We can all share these pain points and even share solutions to mitigate these pain points. One initiative I found from the React Native community is the React Native Upgrade Helper. Some of you might have seen this before. I'm told it was presented at last year's conference. How cool is that? So what this is a tool that helps you, as the name implies, upgrade your React Native version. And it was really cool because I was able to specify what my current React Native version is. You can see on this screenshot, I've set it to 0.55.4 and then pointed to which version I would like to upgrade to. So I went straight to React Native 62. And what it spits out is a series of instructions as well as diffs. Diffs of what? Well, diffs of the core files that come out of initializing a React Native upgrade app. Things like your package JSON, as you can see in this screenshot, some scripts, some dependencies that are pre-pointed to by creating a new React Native app. And you can use this to just make sure that your build files, your Gradle, your Xcode configurations are in line with what the React Native community expects is sort of a baseline for what you're doing when you're building a new React Native app. Now, of course, this isn't meant to be a catch-all. If it were easy, then it would be even more straightforward. So you might be wondering, if I'm not alone, how can I contribute? I think quite firmly that already by undergoing such a procedure of upgrading, you already have a wealth of experience and some unique takes from your perspective that you can apply to someone else who's about to go this for the first time. I like to think that these kinds of contributions would really, if they can affect me from 2, 3, 4 months ago, maybe even longer, then I've already done something good. This can take the shape of, well, a book, a blog post, a talk. When I did this back in April, I wrote a blog post, which has the content of what you're listening to today. Let's go into the next lesson I learned, and that would be to break it down. Now, I'm not a dancer. I'm not going to dance for you today. When I say break it down, I really mean break the problem down into smaller problems, kind of like divide and conquer. Kind of like setting yourself up to have a series of small victories. Allow me to expand. When I initially started this upgrade procedure, I thought, all right, what are the base things I need to do in order to consider this mostly a success? First, get the iOS app running. Once I've done that, I can then focus on the Android build. But until then, I will focus laser-like exclusively on the iOS upgrade. So I took that iOS upgrade and I thought, how can I break this down into smaller chunks? So I did. I adapt to auto-linking, fix compiler errors, fix broken UI elements, fix any bugs or crashes, fix compiler warnings. And by focusing on each of these one at a time, I was able to overcome them. And each time I solved one of these problems, pat myself on the back. Yes, I get myself a little motivation boost, and then I can keep going. So once all that is done, I thought, okay, now I can move on to Android. The list of problems will probably be very similar. And it was, for the most part. You see, I started knocking these out, and all of a sudden I ran into a crash. The React Native app wouldn't compile until I upgraded the React navigation dependency. All right, so I solved that. But that introduced a new issue. Now the app is crashing because of this new React navigation upgrade. So I had to jump in and solve that problem. Now you might think this could deter me or could be quite stressful. And I'm not gonna lie, it was a little bit. I like me a good video game, so one that came to mind while working on this was a very old video game from Nintendo called Greenhouse. And what you do in this game is that you're a greenhouse keeper, and you're making sure that your plants are safe from a series of bugs that are coming to munch on your plants. And so what you would do is you would go over to one of these four corners you can see and just spray the bug deterrent. And I felt that this was quite similar to my experience focusing on these issues. Sure, other parts might break, but no, I gotta get this part working first. And once I solved that problem, I could move on to the next. And by doing so, I kept myself motivated and I could stay focused on one issue at a time. Next came the question of knowing how much I should upgrade a dependency. For example, React Native, you remember I mentioned, was 7 versions behind the current one. So by doing so, you might wonder, why not just upgrade to React Native 59? Looking at React Native 59, that already solves the problem that I was having with Android. It adds that compatibility with 64 bits. Sure, I could totally do that. I also thought to myself, well, I could also upgrade to React Native 60 while I'm at it, because that introduces auto-linking, which is already a huge boost in productivity and makes managing these projects a little easier. But I thought, if I'm going to do that, I might as well upgrade to React Native 62. Why? Well, I thought, why not? With the mentality of, well, I am going to have to upgrade eventually because these mobile OSs keep updating and adding their requirements. It makes sense to stay on to as close a current version of React Native as possible. Keeping the stability, keeping it future-proof, and making my life as a software developer easier without compromising the user experience. Next was a lesson that was reinforced for my software development process. So I thought, hey, if I need to keep a clean history in Git and want to make my life as easy as possible, I was brought on to the concept of bleeding edge branches recently. If you don't know what those are, you can read about them in this link from the official Git book. And I kind of like them. What they are is kind of like a scratch pad in your version control. There, I was able to make tiny, very small commits, most likely broken. That's fine. I don't need to commit to. I don't need to have a commit that takes a very clear step to, and everything is working. It means that I can take these steps and observe how I have upgraded React Native and all the other dependencies to be able to determine that the app is working fine. This also allowed me, once I was done, to clean up the history accordingly, squash it, rebase it, all of that, as well as revert commits when I didn't need them. For example, maybe I broke something that didn't need breaking. I really liked that I could keep this in a sort of silo where I could make all the changes I needed without compromising the work of my fellow developers. Now, this last lesson I learned and I feel like that's more of a discipline thing for me, was knowing when to stop. Now, I don't mean knowing when to stop for the day. I meant knowing when to stop upgrading. How much upgrading is too much upgrading, if that makes sense. See, in this project, there were 72 listed dependencies, which, depending on your experience, might sound like a lot, might not sound like a lot. But the truth of the matter is, I did not need to perform a major upgrade on all of them. For example, say React Native Vector Icons, which is a package for showing icons in your mobile app. I didn't need to upgrade to the latest major version, but maybe the latest minor version. If you're not familiar with it, this is semantic versioning, where developers adhere to a protocol that says the major versions are the API breaking changes that need to be dealt with. A minor version will introduce new features but not break the API, and a patch update will just fix some bugs. And what's important is, if you're not going to upgrade them now, doesn't mean you never will. I needed to be able to provide my client with a semi-timely result where I said, okay, I think this is ready to be deployed. So those are 5 of the lessons I learned that I could apply to my software development skills in other parts. But I also learned some other skills that apply not only to software, but to other parts of my life. Now, I'm not saying I'm ungrateful. On the contrary. One funny story is that when I was blogging about this, and when this talk was announced, a friend of mine reached out to me and said, hey, I saw that you're upgrading this. You might know him, Pavlos. He's gonna talk about Xcode today. And when I saw that he was a contributor, I was so excited. Wow, someone I know, it kind of gives it a real tangibility. I don't know if that makes sense. It really taught me that I really should make more of an effort to reach out to people and say, hey, listen, I couldn't have done this without your work. Thank you so much. You changed everything for me. I think we could all practice that a little more. Another skill I learned was that of patience. I like to... I wouldn't say, I would definitely not say that I'm the move fast and break things kind of person. But I do, after a while, get a little impatient when, several days go by and the end is nowhere in sight. I start getting imposter syndrome and thinking, am I really fit for this line of work as a software developer? But it really helps to remember, we've all been there. Or we probably will in the future. And we probably will again. Another thing to take away that really meant a lot to me was the question, so now that I've done it, am I done? And what I've been implying during this presentation is, no, I'm not. When Apple launches a new iOS version with more breaking changes, when Android introduces some requirements, things are going to have to change, and we're going to have to be ready to upgrade our dependencies for that. Going back to that quote I used earlier, I'm going to just change it a little bit. Imagining if Da Vinci were alive today and, a software developer, maybe he'll say software is never finished, only abandoned. So listen, here's some links to some stuff that really that I wrote up, that blog post I mentioned earlier, and some other links to stuff that really helped me on my journey. Listen, I'd love to hear back from you. If you've got any opinions, hit me up on Twitter. Get in touch. I really appreciate this opportunity to tell my story. I hope you have a wonderful day. Thank you.
All right, thank you, Ramón, for that. I'm always really excited about talks on upgrading, because sooner or later we all have to upgrade a React Native app, so knowing how to do it will just make our lives easier in the future. That wraps it up. That's been the last talk. I hope that you liked it. I hope that you liked the live stream, and in case you had any technical issues or difficulties, we are all sorry for that. We will try to make it better for the next live stream that we will be doing. But that's not what I wanted to talk to you about now. I just wanted to tell you quick few words about like the conference and everything that we did. So that wraps it up. I hope that you liked it. I hope that you enjoyed 2 days of live streaming. This year has been all but the same. Everything's changed and now we are live streaming and I'm standing in front of 2 cameras instead of 400 people, which makes me very nervous about how should I actually do this closing speech as I used to. So all I want to say is I want to thank you for staying with us. I want to thank speakers for doing something extraordinary outside of their comfort zone, for pre-recording the talks, for sending them on time, for being very cooperative. I want to thank Barbara, that's with me in this room as well, for running the conference, for preparing it, the entire CallStack team, the entire marketing team here at CallStack, and the team behind the live stream and the gods of YouTube for making this run smoothly. I hope that did run smoothly actually. So it's been all great. And you know, I wanted to tell you that this year we were not really sure if we want to make the conference happen because of the pandemic. We had to cancel the on-site conference. It's been always very aligned with our mission of enabling people all around the world to actually learn about React Native, to learn from the people that actually contribute to the framework on the latest features, on how to build apps in production, and how to solve some of the challenges that they are facing. And so I'm really excited to see so many of you here on the live stream, and that's why we are going to be hosting a Q&A in a follow-up on our React Native podcast so that we can answer some of the questions that you still have. So I'm hoping that we'll see each other next year here in Wrocław on site, and you will get to know what is it to be here in Wrocław, how does it feel to be in Poland. And now if you don't want to take my words for granted, you don't have to, you can ask Ken Wheeler, for example. I think he remember, or maybe not, the night here in Wrocław, but it's been all fun for him. And meanwhile, all I can tell you is that we have a upcoming podcast with Q&A session. So join us on our Discord channel again, where you can stay tuned stay tuned to the updates as they arrive. And follow us on Twitter so that you will not miss an opportunity to be part of the conference next year. Stay safe, good luck with your technical and React Native challenges, and see you next year at React Native EU 2021, hopefully in Wrocław, Poland, if not on this YouTube channel. Bye bye.